Okay, are we live? Great. Let me check. Anyway, okay, so welcome students, Mr. Gan. So we have already compiled 100 H2 Math integral questions for you to practice. Please do check out. You can download the worksheet from the link below. All right, so this 100 integral, I'll just do it one shot. The aim of this live stream is just to address some of the common questions you'll see in the exam and what are some of the techniques that we use to do integration. Okay, then I just want to frame this question here, but that is this 100 integrals are for the new H2 Math syllabus, which is for students who are taking the math H2 Math in 2025 for as a level. So for students who are taking the A level this year, just remember the only thing which is not here is this sixth question, which is using factor formula. Okay, so I I already uploaded the video solutions to these 6 questions here, so you can go and refer them. Remember to revise this for your this year's A level, whereas for this year's J1s we won't be doing these 6 integrals here. Okay, so that's it. I hope that you could use this video like as your you use it to revise your integral. Okay, so we're gonna look at this 100 integrals. So before we start, just a reminder that you need your MF27 or your MF26. All right, the integrals, it could be easily found online. Just search for MF27. These are the integrals given in the formula booklet. Okay, and I will not be using the standard F prime fx way of solving. So generally, this is the top process of solving integration. So usually, what I'll say is that follow this flow chart here, okay, and it works most of the time. You just follow it. It will usually you have been working for a few years, right? So it should be working this time around. So you obviously, when you see an integral, the reason why it can be so confusing is because there are so many ways to approach it, right? So the first thing is to know standard integrals from a secondary school level. So these are the basic integrals you have. Okay. Oh, these are the excerpts from our H2 Math summary notes, which you could actually find it from Shopee, Lazada, or even popular bookstore. So you can just go grab a copy. Our H2 Math summary booklet comes with video solutions as well. So you can make it as your study companion if you want to. Okay. So standard. Okay. So then after your standard integral, you have got your recognizable form, which is what I call the is actually u-substitution. So it's a cancelling method. Now the reason why I use u-substitution other than what is given in most notes, right, is because I feel that if we're going to use F prime, I usually teach my students using the u-substitution is because firstly, if you go online calculator, in fact, a lot of the countries were using u-substitution. So it's a way of like telling you how the F prime fx works, because in our H2 Math syllabus, the only thing that is stated in the syllabus are these two, I believe, is this two thing here, if I'm not mistaken. If you search for H2 Math, the only thing which is integral are these two. But you know that some notes you have half a page in the whole chapter, you have a page of this F prime fx. Some have got like 3-4 pages. So it depends on which school you're in. Like really, like you feel like you need to memorize a lot of things, but actually you don't really need to memorize a lot of things. Where you can just use the u-substitution. So how does the u-substitution work? Is that you typically let u be a term. You cancel off something so that it becomes a secondary school NIP or MF27 integrals. Something which you can handle. Okay. So don't worry, it's perfectly acceptable at A level because this is actually international. Like everyone just uses this. So and it's mathematically grounded. So I have heard like some complaints that it's not mathematically grounded, but it's not obviously not my theorem. It's just basically a reverse. So using this method here, we actually you don't have to go and memorize. Rather, you just have to know your secondary school integrals and your MF27 integrals. That's all you need to know. Okay, so I'll just show you how it works, then you understand. So we start with the first question. Okay, so I know that. So we start with the first question. How do you actually use the u-substitution method? So this case here. Okay, so let me look at this. So for the first question here, what you need to understand is that we have got x squared and x cubed plus 3 cubed dx. Okay, so how does the u-substitution method work? You know that this cube here, if I let u be this guy, I'll cancel the guy in front here. Essentially what I'm saying is like if u is x cubed plus 3, okay, then you know that du dx is actually 3x squared. Okay, so this will tell you that dx is actually du over 3x squared. Okay, so you can actually just replace this in. Now I know some schools don't allow you to do this, then you just erase it. It's just a guide, but like I said to my student, all these things can be found in university textbooks, so it's not something we don't write it like that. Okay, but if a school don't allow it, then just erase it. It's fine. I am not I have nothing to. Yes, so this is 3x squared, so you just understand that when you let this be u, you just need to put the derivative below it. Okay, so you just put the derivative below it, so that this guy here would essentially, what happens is it becomes a secondary school integral here, which is 1/3. Okay, 1/3 u cubed du, and then 1/3 u4 over 4. Okay, obviously this is not your final answer. Please don't list your final answer as this case here. So what you need to do is just substitute your u back in. So this will be x cubed plus 3 to the power 4 plus c. Okay, that's that. Let me check. Okay, I need to. Okay, that's that. So that's the first first question, right? Let me just put my answer on the screen, then I'll be able to see. Okay, so one question now, 99 questions to go. I think I can quickly speed it up. So done, this guy is done. All right, then you're gonna do the number 2. So number 2, similarly, this is number 1. So number 2, what we have is if you think about it, similarly, we could cancel it, right? So this guy, we have 5x4 plus 4x x5 plus 2x squared plus 1 cubed dx. So this guy is my u. So you can just quickly let this be your u, 5x to the power 4 plus 4x. Right, this is your u to the power 3. You differentiate this, you get 5x to the power 4 plus 4x, right? So you could just cancel it. And what is left behind is just a u. I'll just do this as a side quest. So this will just be u4 over 4 plus c. Okay, that's that. Then what you do is just u x over 5 plus 2x squared plus 1 to the power 4 over 4 plus c. Okay, so that's the answer for number 2. I think it's pretty okay. Then we're going to look at number 3. Number 3, similarly, we have got 3x. So done with it, number 2. Look at number 3, right? Number 3, we have 3x minus 2. 3x minus 2 over 3x squared minus 4x minus 1 cubed, right? Dx. Similarly, what we're going to do is just let u be this guy. This is my u. So let u be that. Okay. So let u be that guy. Then what we get is, because we this over here, 3x squared minus 4x minus 1. If I differentiate this, it will be a multiple of the top. It will be 6x minus 4, which we can cancel the one on top. So the idea is just cancel it so that it becomes, so you put the derivative below 6x minus 4. You must always evaluate. Okay, this is 1 and this is 2. So we will get this as half u minus 3 du. So this case here, what we get is half u plus 1, which is minus 2, then plus c. So this guy will just be minus 1/4 3x squared minus 4x minus 1 minus 2 plus c. Question 3. Okay. Yep, I think that's it. So let's look at question 4. So question 4, we have got this guy. Similarly, you can see that if you let your u be this, you can cancel it on top, right? So it's all about cancelling. Like you cancel it so that it becomes something you can actually integrate, right? So this guy will be x squared x cubed plus 1 dx. So this is let u equals to x cubed plus 1. So this is x squared over square root u du 3x squared. So cancel away. There will be 1/3. So I'll use u minus u. This is a secondary school integral. So of course you can skip here if you want to. Like you could just skip this step once you get proficient, right? So this will be 2/3 of 2/3 of u to the power half. So it's x cubed plus 1 plus c. Okay, so that's part 4. Question 4 done. So let's look at 5. I'm just going to quickly go through the rest. So for those of you who just tune in, just remember you can just download the questions. So 5, we have got 21x. Now the questions will get harder. So we just getting accustomed to the idea of like u substitution cancelling method. So this guy, you differentiate this. I think you could cancel the one the top guy. You could cancel. Factorize the 7 out. I think 3x squared plus 2. So it's actually the u here. So you always try the u substitute for the one inside. Okay, be inside the bracket or inside the root. It's usually those. Then this is the u. It's 3x squared plus 2. So this guy will be 1. So of course this step, if you are very proficient, you can also skip it. Okay, so I'm just gonna write it at the side here. This will just be your half. So this is 7u half over half plus c. So this will be your 14 square root x cubed plus 2x plus 1 plus c. Okay, that is question 5. I think it's pretty okay. So let's look at question 6. Okay, question 6. Question 6 is this guy. Oh, now it gets interesting. Okay, so now we sort of get the hang of like cancelling u substitution. Okay, so okay, the easier questions obviously if you want to use the school f prime f(x) is easy, but u substitution helps you when you when the expression gets harder and harder. Sorry, I copied the wrong stuff. This is 1 minus 2x squared. Okay, this is interesting. Okay, now technically when you let your u be this guy, you cancel it off. You cannot cancel the one on top because you get negative 10x. So what you're going to do is just split it up. So when you split it up, this guy will be over here, 1 minus 2x squared dx. Then the other one will be over here. Okay, now if on top is constant and bottom is a root of a quadratic or like a quadratic factor, a quadratic expression, then it's definitely what do you call it? It's definitely it goes here. Okay, so you it's not cancelling method. Then you have to figure this thing out. So you need to do long division. But if top is a constant, then you complete the square. Then you use m(27). So this case here, obviously the top is a constant, right? The top is a constant. So you need to use m(27). So this guy here, you use u substitution. So this guy will just be x over square root u du. So this is my u minus 4x. Okay, whereas this guy, just be mindful. I think the problem here is usually student would have remember to divide by the coefficient of x, which is if you want to do it this way, you open square, remember to divide by this. A lot of students will forget to do that. Okay, the idea is very simple. Now your u is, so your u now for this guy, this integral here, is actually square root 2x. Okay, so don't forget, the way you see it is that basically now you see you're substituting u as this guy, so that's why you need to divide by root 2 if you want to. Okay, so but that is the idea, that's the main idea. So this du, then this guy will just be using MF20 and MF27 from you get sine inverse root 2x over 1 over square root 2. Okay, because divide by the coefficient of x. Divide by coefficient of x. Okay, then you plus a c. That's that. So this guy will just be plus half divided by half to be minus be half. Okay, so you minus half du. This will be u half over half plus c. So it's 2. So this will be 2 square root u plus c, right? So essentially this is just 1/4 2 square root 1 minus 2x squared. Okay, of course you can skip step if you want to. So then this will be just 5 over root 2 sine inverse square root 2x. I think I'll just rewrite them. It's minus half 1 minus 2x squared. It's 5 over root 2 sine inverse 2x plus c. Okay, so speed it up. So one is MF2060, one is cancelling. So let's look at next question. Next question is question 7. So question 7, let's look at that. Question 7, just be mindful, this is x. This is square root 3, 4 minus 1, power 3 dx. So this is similar to one of the past year question. So the cube, you just multiply, okay, the is okay, this cube here. Then the bottom here is 3x4 minus 1, then 3 over 2 dx. So I'm going to let my u be this guy. So it's quite straightforward. So u is just 3x over 4 minus 1. So that will be, I'm just going to bring it up because it's easier to see. 3 over 2 du, so it's 12x cubed, right? So this will be 1 over 12 u minus 3 over 2 du. Then I will get this guy 1/12 u plus 1 is minus half plus c, right? So then this will be negative 1 over 6, I believe. And I'll put this as 6 square root 3x4 minus 1 plus c. Okay. Yeah, looks good. So far, so good. Great. So this is question answer. So eyeball, you need that to be cancelled away. So that's why. Okay, let's look at question 8. So this is quite clear cut also. This is just your typical ln. Okay, so you can just obviously if you want to, you can use the f prime fx method for this. It's relatively easy. So it's you can just let your u be x4. So this is u is just, can maybe I just rewrite this dx. So u is just x4 plus 3 because we will cancel the x cube on top. So this is x cube. U du, this is 4x cubed. So this is 1/4 4 ln x4 plus 3. Okay, so I didn't do the intermediate step because it's quite clear. It's just a ln. That's all. Great. It is done. Then we're going to do at 9. Okay, 9 will just be this guy here. Can you do cancelling to 4x plus 2? Yeah, okay, so you differentiate this. You can see that you get 4x plus 2. So you can also get the cancelling on top, right? So that's the idea. So let's try that. Number 9. Number 9 we have got, is it 9? 9 we have got 2x plus 1 over, so I can just do it quick. 2x squared plus 2x plus 5 dx. Okay, this is my u. The bottom will be my u. Du will be 4x plus 2. So this will be cancelled away, So this is just be half ln u. Okay, so the idea is very simple. Cancel, reduce to a secondary school form, MF27 form, and then that's all. Then we look at number 10. Oh, number 10 is fun. Okay, let's look at that. 10 is a bit, 10 will be fun. So 10 is x square root 1 minus 4x minus x squared dx. Okay, this guy here, you know that you cannot cancel. You substitute the u here, you can't cancel the one on top. So what do you do then? Okay, so you know that is basically it's not you don't need to do long division, and at the same time you don't really need to like what do you call it? Yeah, you can't cancel straight up. So if you look at the flow chart, this will be the last resort for algebraic fraction. So it will be the split up method. So essentially, if you exhaust everything, you talk about the split up. So how does the split up work? Okay, the split up is very simple. You just want to split it up such that one side will be cancelling method, the other side will just be MF27. Okay, so this guy inside here, what you do is you just put the derivative inside here. So this would be our differentiate. This guy will be what is it? Quickly, this guy will be -4 minus 2x. Okay, so what you do is then you do the secondary school separation, find the a and b, right? So that's all. So it's x equals to a minus 4x. I'm just doing side quest a bit. Side quest where here. So it will be x equals to a minus 4 minus 2x plus b. So this case here, what we get is a minus 2a. The coefficient of x is 1. So a is just minus half. Then we have minus 4a plus b is equals to 0. So I put minus half in, will be 2b will be -2, I think. Right? So -4, 2, yeah, that's it. So then this guy, what we'll get is actually when you split it up with half, -4 minus 2x square root 1 minus 4x plus x squared dx minus 2 1 over square root 1 minus 4x minus x squared dx. Okay, so this case, obviously this is just cancelling all your f prime fx. Then this guy is just mf27. Okay, so when you do the mf27, what you need to understand is you just complete the square. Okay, so just side quest again. Let's side quest a bit. Just side quest. So 1 minus 4x minus x squared, right? So complete the square, x squared plus 4x, I believe. This would be 1 minus x plus 2 square minus 2 square. So this will be 4. That'll be 5. I think plus square root. Okay, so complete the square. Great. Side quest. Then yeah, that's that. This is question 10. Okay, great. So then this guy, obviously the u is this inside here. This is your u. So that will be -4 minus 2x u du. So it's -4 minus 2x. Yeah, this guy will be 2. Then you just basically just do this guy. Then you will have you have sine inverse. Yeah, sine inverse, right? So sine inverse x plus 2 over root 5. Then that's it. What else I need? So this guy will be cancel it off. Then that will be minus half du. This will be sine inverse plus 2 over root 5 plus c. Okay, so this will be u half over half. So it's you get square root x. So you just do this will be square root u. Remember, I just do it half over half. This will be 2 sine inverse x plus 2 over root 5 plus c minus square root u is 1 minus 4x minus x squared. Great. Okay, this is pretty okay, I think. Let me check. I think my answer here may be wrong. Hold on. I hope I have no careless over here. Yeah, it doesn't seem like it. Any careless? B is plus. Okay, my answer doesn't tally with I know there's some I'm just gonna check my answer before I Okay, so answer is correct. Anyway, thankfully answer is correct. Yeah. So as in my answer here is correct. Yeah. Okay, great. My reference answer key is not right. Let's look at the next one. Question 11. My goodness, I only finished question 10. X squared plus 4. X. Okay, great. So similarly for question 11. Question 11. Question 11. What will happen is actually you will get is x plus 4. Then this will just be x squared plus x plus 1 dx. Okay. Similarly, if you can see that if you differentiate, this is x, the denominator is 2x plus 1, which is you can't cancel one on top. Then you ask yourself, you run down the list, right? You ask yourself whether you need to do what do you call it, run down the flow chart here, whether you need to do long division. You don't need to, it's already a proper fraction. Then whether the top is a and so on and so on and so forth. Then you realize actually 1 to 3 will be exhausted. That's why lastly you use split up method. So how do you do split up method? Similarly, you just put the a bracket plus b. Then all you need to do, all you need to do is just to put this guy inside middle here. So this is 2x plus 1, the derivative of this guy, so that you can leverage on the fact that you can use cancelling method. Okay, so I think that's all. So then we have got x plus 4 equals to 2a. Sorry, a. Okay, a 2x plus 1 plus b. So 2a is equals to 1, a equals to half. Then you have a plus b equals to 4. Okay, b is equals to 4 minus a, 4 minus half. That will be 7 over 2. Okay. Great. Then I'm just going to split it up. So this is half 2x plus 1, x squared plus x plus 1 dx. Then this will be 7 over 2. Obviously the guy below, we just need to complete the square. Okay, so the guy below here will be x plus half square minus half square plus 1 dx. This guy is just cancelling, so it's a very clear cancelling, so it is half. Then here I would suggest, once you understand cancelling, you can just use the f prime fx. It's faster. Then this 1/4, so this will be 3/4 when you complete the square. So then that will be 7 over 2. You use MF20, you use MF20, 27 here. It'll be 1 over a tangent inverse x over a. So it's 1. The a is this guy. Just take note. This is your a. Okay, maybe I just rewrite this so that we don't have any confusion here. So square root 3 over 2 square dx. Okay, so this will be half ln x squared plus x plus 1 equals to plus 7 over 2, 1 over a tangent inverse x plus half a root 3 over 2 plus c. So then how do we just multiply by 2 throughout? Then what we get is we get 7 over root 3. You can of course bring this half above, then just look nicer. Okay, then this cancel away to be 7 over root 3. Tangent inverse 2x plus 1 over root 3. Okay, that's it. So that's how I do question 11. So we look at question 12. We have we already 2x plus so this so be mindful, not everything is so always check whether it's cancelling. So this is clearly cancelling. 2x plus 1 x squared plus x plus 1 dx. So u is equals to x squared plus x plus 1. This is just ln 2x plus 1. It's 2x plus 1. Then there will be cancelling. So it's ln. Just cancel nicely. Then you replace the u back. Done. Question 12. Then we're gonna do question 13. Oh, nice, great. Question 13. Okay, by now I hope you already have the worksheet. Okay, I'm just not gonna refer to the worksheet anymore. Then we just okay, here. Question 13. What we have is just this is where cancelling method shines, because it's very hard to see f prime x if it's like a root x, right? Now what you need to understand is one of the common trick we like to use, or rather we like to test, is that du dx, right, is nothing more than just a reciprocal of root x, a multiple of it, half of reciprocal of root x. Meaning to say, see this as a root x. Okay, so what I'm saying is, you look at this root x in front. Okay, there are few, so it's u9, right? Du. Just remember, this root x can be cancelled out each other. Okay, so this would be super good, because if you're gonna there you go, u minus a over minus 8 plus c. So this is negative 1/4 u minus 8 plus c. So I'm just gonna do that. So this will be negative 1 over 4. Make it look nice, will be root x plus 1, 8 plus c. Done. Okay. So the derivative of u root x is a reciprocal of the root x itself. So we look at question 14. 14, we have got same thing. So you have got 1 over root x here. Then you have 1 over e root x. Okay, there are a few ways of doing this, which is interesting. So some students you like to okay, so I'm probably going to just explore a few ways. I think the better one would be you let u be, maybe I just put method 1. Let u be root x. Okay, so this is 1 over root x. So this is eu du. You know that is half root x. Cancel it away. So this guy will be 2e minus u du. This is a secondary school integral. So minus 1 plus c. So that will be given us by minus 2e minus root x plus c. Okay, done. This is first method. Method 2 would be some students will let the entire thing be root x. I think it works as well, but it's gonna be very shack. Okay, so but okay, we will just explore that for the sake of it. This guy will be here. Here will be like root x. It works as well, I think. So du. So you differentiate this root x. Okay, half root x. Okay, so this will cancel away as well. Cancel away. So then don't forget this is e root x. Okay, you're in the world of u. So if you is u, just remove your x. Okay, so this is a u. E root x is u, so you can just make this u again. There, you get u minus 2 du. Then similarly, you get 2 minus 1 over minus 1 plus c. So using u substitution give you an array of way to solve integral, which is very fun if you know what you're doing. Yeah, but I mean, yeah, which is give you an idea of like how powerful it is. Because if you're gonna stick with just f prime fx, sometimes it's very hard to concretize or really write down what the integral, like you can't really present the concept very fully by using f prime fx, or you use u substitution is as clear as day. Okay, so that's what I'm gonna say. So we're gonna look at 15. So similarly for 15, another trick that we like to use is that if this is ln x power 8, okay, we like to use, we know du dx is a reciprocal of 1 over x, right? So maybe this guy here, what I like to do is u8 du 1 over x. Okay, so you can just cancel the 1 over x in front. Life is good, everyone's happy, yay, good job. Okay, so you get u9 over 9 plus c. So very simply put it, this would just be ln x to the power 9 plus c. Okay, now you realize I don't need to do any memory work when it comes to integration, right? So it's really just use substitution. You use secondary school. There's nothing that I don't need to approach integration in the memory form. Like I just need my secondary school integrals. And what I learned in secondary school, then what is in the MF27, right? So, in my teaching experience, I've seen many students approaching integration like really just in memory work. Don't do that. It's really not good for health. Okay, so that's that. So you look at that is 15, right? Now we're gonna look at 16. Okay, 16 is this guy here, man. 16, okay. So this guy, okay. Oh, the other thing you have to be mindful is, so maybe I talk about the difference. So this is x ln x cubed dx. There's a difference between this and this. Okay. So I think the difference is stark and maybe it's worth noting. If you have got, say, ln x to the power 3, this just means ln x multiplied by ln x multiplied by ln x 3 times. Okay, so don't get confused. So ln x to the power 3 means this 3 can be brought down, ln 3x as such. So the difference is this guy can be brought down to the front. So this will be 1/3 x ln x dx. Okay, now then same thing, your u should be ln x because you can cancel the u in front there. So 1 over x, 1 over u du. This is 1 over x. So you cancel this guy, bro. Easy game. So 1/3 ln x plus c. Okay, that's it. But of course, you want to talk about this, then this will be similar to this guy in front here, which is the previous part. It's exactly the same. So same thing, your u should be this. Du 1 over x, cancel it out. Then this will be u minus 3 du, u minus 2 plus c. Then you have got ln x3. Ta-da! Okay, so u substitution method works like a charm. Okay, next, what we do is this. Oh my goodness, good. Maybe just with 17. 17 will be x ex square minus 1 dx. So what I do is just sum them, add them up, the power. Okay, maybe I just slowly do it. Sum them up, then these two added up together, e2x square minus 1 dx. So remember your u is 2x square minus 1. You will be able to cancel the front in front there. EU du 4x. So this will be 1e 2x squared. Okay, plus c. Okay, there you go. E 2x squared minus 1 plus c. Done. What else need to do? Okay, now we can finish up too. Okay, we're going to start with 18. okay, this is where the fun begins. So now we look at this guy, 18. This is 1 plus e minus x. So this is where you have to know that you need to rearrange first before you start integrating. You have to basically try and rearrange this. So your u, if you sub this as a u, you can't cancel something on top, right? So what you need to do is, a common trick we do is we multiply by ex. Okay, but if you ex here, so that when we multiply, we force something on top to be cancelled. Okay, ex multiplied by e minus x. The good thing is this will become 1 because note ex dot e minus x. This is ex minus x, which is e0, which is actually 1. Okay, so or you can just see this as ex 1 over ex. It's also 1. Okay, same thing, whichever floats your boat. Now then, this will be super convenient now, because now we can let our eu be the denominator here. Then this will be ex. Then this will be cancel it out. Then this will just be ln u lah. Okay, so many things to do. So many things to do. Okay, good. Okay, number 8. Done. Look at number 19. 19 is x7. Oh, okay. x8 plus 2 dx. So you let your u be this guy, because this guy will cancel the x about 7 in front. So cosine u du. This is 8x7. Okay, cancel it out. So this guy will be 1 over 8 integral of cosine u du. This is 1 over 8 sine u plus c. So this is 1 over 8 sine x8 plus 2 plus c. Okay, that's 19. Okay, so sine x squared plus 2, yeah, great. All right. I haven't been checking my final answer. I should. Right. Anyway, let me check. I should be checking them. Yeah, okay. Looks is okay. Okay. So anyway, done. All right. So now this is the fun part. Okay. So for trigo identity, is that okay? It gets harder subsequently. So like for example, if you have tangent about 5, you have to be very careful with the trigo identities, because you need to know differentiate tangent is secant square, differentiate chord is negative cosecant square. Then how do you cancel them? Then the problem with trigo identity is sometimes it's not so easy to see it's cancelling at first, but generally as you have to acquire the skill. Then if it's not cancelling method, then you have to change to any of these 8 expression here, because there are only these 8 you are able to integrate, right? What I meant is you don't need to memorize, because you already learned sine, cosine, secant square in secondary school. Cosecant square, some IP schools have already learned. Some O level, your main school JEE, you likely have not learned cosecant square. But integrating cosecant square is just negative chord, right? So remember that all these, then after MF27 you have this. So if cancelling method doesn't work, what you need to do is just change to any of these 8 and then start integrating. Okay, this box is the harder ones, because trigo identities, as you know, in secondary school we have very strong foundation, right? We love our trigo identities, right? That's why we are very yeah. So change it to any of the 8. Then after that you need to leverage on the expression, all these trigo identities here to help you. Okay, later on we'll see some of the questions, then we'll be able to see. So anyway, this guy, okay, this guy will just be, okay, secant square and tangent are very closely related. Okay, so what I will say is, when you do your cancelling method, right, you have to understand that yeah, you can cancel the secant square, and also, sorry, I lost my train of thought. Tangent x, secant square. Oh yeah, and also you must understand that some formula are not given in MF27. Okay, So like sine square A plus cosine square A equals to 1. This is not given. Then after which you divide by then tangent square A plus 1 equals to secant square A. This is also not given. Okay, so but what I will say is you derive it. Okay, every time you need to use this, make a habit to derive it because it's not hard. And then you have you don't memorize it because I mean you have so many other subjects to memorize it. Why would you want to yeah, what do you call it? Cram it in your head. So usually just memorize this, all this. So this case here is a cancelling method. It's just my u is equal to tangent x. So very clearly, this guy will just be secant square x, u5 du secant square x. This is u6 over 6 plus c. So this will just be tangent 6x over 6 plus c. Done. Okay. The beautiful thing about trigo integral, I think this may not be the only way to solve this, but yeah, I think you can solve other ways as well. But yeah, I'll just stick to this first. Then similarly to 21. 21, what you have got is 1 over sine square x, tangent x, right? Dx. So this guy would just be cosecant square x. This is cot x dx. So similarly, your u should be cot x. Okay, because you can cancel you can cancel du. Differentiating cot will be negative cosecant square x. You can cancel this guy, man. So this guy will be minus u du. Then this is minus u squared over 2 plus c. Easy game. Let me see. 21. Cot square x over 2 plus c. 21. Okay, great. Yeah, that's 21. Then we look at 22. Wow, okay. That's fun. 22. You have got sine x, cosine x, sine square x. This is fun because the fun fact is that the entire u here, you just differentiate u, that your u be sine x squared. So it may not look like they're related, but when you du dx, you get the multiple of sine x cosine. So sine x cosine x plus 14 cosine x minus sine x. Correct. So you get negative 12 sine x cosine x. Okay, there you go. So what you'll get is differential cosine. Yeah, so this guy will be sine x cosine x over u du minus 12 sine x. So you realize it's just minus 1 over 12. You can cancel these, right? Then you get minus 1, sorry. This will be du. So minus, this will be ln. Equating this is ln sine square x plus 7 cosine square x plus c. Okay, that's it. This is 22. Yes, great. Let's look at 23. Oh my goodness, I'm only a quarter away. Okay, I'm speed it up. 23. Oh, 23 is the same thing. 23. So once you know the trig, shouldn't be an issue. What you need to understand is also that that if you have a angle which is like 2x, then you change to the same angle. So you use 2 sine x cosine x over 5. Let this be u. So I know my u is actually 5 sine x square plus 4 cosine x square du dx 10 sine x. Differentiate sine is cosine x. 8 cosine x. Then this negative sine x. This will give us a grand total of 2 sine x cosine x. Okay. Oh, wow. Okay, then this is u minus half du. Great. Then this is u half over half. Then this is just u 2 square root by sine 2x plus 4 cos square 2x plus c. Okay, so that's that. 23, right? Yes. 24. 24. 20. Oh, wow. Okay, 24 is this guy. Okay, but negative. Okay, this is interesting. This is by parts. Let's do 24. Maybe a new page. Okay, so this guy here, you have two parts, right? Is minus e sine x or sine x here dx. You can use Liate by parts. This one is two parts here, so it will basically you have got if you're using Liate, this is exponential, then this is trigo, so Liate. Okay, this is obviously not cancelling. So if it's not cancelling, it is not algebraic, and then this is not purely trigo function. So it has to be the last resort. Okay, so you think about it. This is how you do it. The way you think. This is the last resort. If this doesn't work, I don't know what will work really. Okay, maybe it's not in your syllabus, but that's the idea. So when you do this guy here, what you know is I have got e and t. So my u has to be sine x. Okay, then my dv dt is actually just dv dx. Sorry, dv dx is e minus x. Du dx will be cosine x. Then v will just be e minus x, then minus negative divided by the coefficient of ex. So when you do this, is uv, u, v. So usually just multiply in like that. Minus of v du dx. Like that. Okay. Then you slowly do it, e minus x sine x plus e minus x cosine x. Then you do the same thing, another by parts, right? So this case here, you do another u1 is cosine x. Don't keep to the same same cosine. So if u it was trigo previously, you just keep it to the same. Don't swap it. Later you will get a wrong one. du1 dx will be negative sine x. V still equals to minus e minus x. Okay, so that's it. So then this case here, minus e minus x sine x plus uv minus of. Okay, let me just label it for you. Maybe I label this out. uv minus v du dx. Okay, similarly, this guy is uv sorry, uv v minus. Okay, so how do we do this? Minus e minus x. Okay, here. This guy. Bro, hear me out. I have a proposition to make, right? If you are the part of the problem and you're also part of the solution, obviously you're the problem, right? So you have to understand that you should stop, because if you're gonna continue on with this integration, you're gonna repeat the same step. So if you're part of problem, so what you need to do is actually just see this entire thing as an entity here, e minus x sine x. So typically what we'll do is let this say, for example, this be I, this be I. Okay, you bring the entire thing over, so it's 2i. You get a 2i equals to minus e minus x. I factorize this sine x. Okay, so I will just be minus half e minus x sine x plus cosine x. So the integral here will be e minus x sine x dx equals to minus half e minus x sine x plus cosine x plus c. That's that. This is which question? 24. Why I got an extra negative? Oh, this is plus. Am I right? dv dx negative. I didn't copy wrongly, right? Yeah, okay. Answer for... Okay, correct. Thankfully, my answer is correct. Yeah, hold on. My answer key is wrong again. $24 done. Okay, let's look at 25. 25. So 25 we have got sine x e cosine x dx. Similarly, let this be u. So this will be sine x eu du over negative sine x. Cancel this out. Be minus 1. Differentiate cosine is negative sine. It's minus eu plus c minus e cosine x plus c. Okay, not a problem here. Obviously, you can just use f prime of x. I don't think it's an issue. Let's look at part 26. Okay, so let's look at that. $26 will be... I'm only halfway there. That's 2x. Okay, there are a few ways to think about this. One is you make use of okay, one is you make use of e ln a is equals to a. Okay, so you just do this in the sense that your this is just change it. So you change it to this is method 1. I think as e ln a equals to a. So I often joke that e ln mass is equals to mass with my student, and often it sticks. So e ln mass equals to mass. Okay, so e ln a equals to a. So anyway, this is your a. So this is e ln 2x dx. Okay, the x will bring it down. This is e x ln 2 dx. Now this is nothing more than just like e a x dx. The a is this guy, constant a. So this is e a x divided by a plus c, right? So similarly, what you do is just e x ln 2 over ln 2 plus c. Okay, so this guy, what we get is but this guy is just 2. This guy in front is just 2x ln 2 plus c. We get this. Okay, but I think sometimes students get overwhelmed with this. So what you can do is you let your u-substitution comes in. It works as well. So how you let your u-substitution work is that you method 2, you let u equals ln 2x. It works as well. So this guy will just be 2x dx u equals to 2. Okay, so you already learned the derivative of u du. This will be 2x ln 2. Okay, so you know that this will be u 2x du 1 over ln 2. The 2x cannot be brought out because it's a variable. Then this guy here is actually your u. So you get 1 over ln 2 u over u du, which is 1. So 1 over ln 2 integration 1 will just be 1 ln 2 2x plus c. Works as well. Okay, so either way, whichever floats your boat, just make sure your boat is floating. Okay, that's all. Then let's look at 27. Okay, this is where the stream. Oh, right. 27 was is the fun part also. 27 is are they the same? They are. Did I? Oh wow. So many different. Oh. Is there any repeat question here? Oh, doesn't seem like it, huh? Okay. Wow. Okay. So you have to be able to tell the difference between 27 to 35 here. So you have to nail them down one by one. Well, okay. So how would you do? Wow. Okay, okay. I think we look at 27 first. 27. Okay, 27, they are all linked. So let's look at that. 27. We have got 27 will be integration of 1 over 4. When this is nothing more than just a secondary school ln 4 minus 9x divided by the coefficient of x plus c. So this is 1 over 9 ln 4 minus 9x plus c. Okay, not an issue. I think this will be an issue. 28. 28, what you have is actually, now look at the difference here, is 4 9x squared dx. Now, take note, if it's a quadratic, then top is a constant. That definitely this is MF20, MF27, right? So this guy would then be, actually you could use partial fraction if you want to, because it could be factorized. But since we are given the formula, then we might as well just take it in. So I'm going to use this formula here, okay? So it will be this guy here, a square minus b square. So I'm gonna take it down. I don't really remember the formula. I'm gonna just view it on my screen. Okay, so you have got this is x squared minus a squared. A squared minus x squared. So it's 1 over 2a, which is 2, ln a is 2 plus 3x, I think, over 2 minus 3x plus c. Now, this is where a lot of students will make a careless mistake, which is they oftentimes, even I will do this mistake if I don't pay attention, is oftentimes they don't divide by the coefficient of x. Okay, so you, like I say, you can see that now you're integrating with respect to 3x. Your u now is 3x. So you differentiate 3x is divided by 3. That's why you have the extra 3 there. So this is super important. This guy here, this is 12. Then this is ln 2 plus 3x. 2 minus 3x plus c. Okay. I hope I look at the right one. Okay, then this is what is this question here? This is 28. Yeah, correct. Then we look at 29. So we have 29 would be x over 4 minus 9x squared dx. So this is by cancelling, because we can cancel something on top. This is x over u du minus 18x. Cancel it out will be minus 1 over 18, 1 over u du. Okay, so this guy cancel it out. Cancel. So it will be ln u. So minus 1 over 18 ln 4 minus 9x squared plus c. Okay, so always go through the list that provided, right? The hierarchy. Just always check whether you need to use cancel. Then if not, you move on down to the next step and so on. So this is it. So 30. We look at 30. 30 would be here, x plus 3 over 4 minus 9 x squared dx. So this guy would be same thing. You split it up. 4 minus 9x squared, 4 minus 9x squared. Okay, so this is similar to this, exactly the same. So I'm gonna do, I'm just copy answer from there because I'm lazy to. Then this is just this guy. It's just using MF, right? So it's same as this guy. 4 minus 9. Is it 4 minus? Yeah, there you go. So I just copy the answer there. So part 30, you will get minus 1 over 18 ln 4 minus 9x squared plus 3 1 over 3 times. So this is from 29. This is from, bro, what is this from? This is from 28. Okay. Then what I'll get is 1 over 18 ln 4 minus 9x squared plus 1/4 ln 2 plus 3x 2 minus 3x plus c. Okay, 30 done. 30. Okay, let's look at part 31. 31 will be x squared over 4 minus 9x squared dx. Then what you do is, when it's improper fraction, quickly do a long division. Don't ask question. Just do long division. So this guy will be minus x squared. So side quest. I'll use another color for side questing. So this guy will be x squared minus 9x squared plus 4 minus 1 over 9 x squared minus 4 over 9. Minus it out, be 4 over 9. That will give us 1 minus 1 over 9 plus 4 over 9. 4 minus 9x squared dx. Similarly, this guy will be just minus 1 over 9x. Just integrate this, will be 1 over 9x, right? Okay, maybe I'll just put this dx here. Okay, not so nice. Not so nice. I'll put this down. So this will be minus 1 over 9x. Then this guy, you just use MF 27. You get from what, bro? Same thing. Wow, I need to keep referring. My eye is not helping me. 1 minus 4 9x is question 28, which is 1 over 12. 1 over 12 ln 2 plus 3x 2 minus 3x. Cancel it out. Minus 1 over 9x. 4. Okay, I'm going to use calculator here. I'm too lazy to think. 1 over 27. Yeah, actually, yeah, like just 1 over 27 ln. Okay, great. That is 31. Then done. 31. Okay, then 32. My goodness, this is a stretch of like curveball. So 32. So you have to be able to handle the different types of integral here because they really challenges your assumption. They challenge your assumption. So let you, this guy, I know like you would be this guy. Obviously I could cancel the one on top, right? So it's x over 1 over u du 18x, cancel it out. I will get minus 1 over 18. Okay. This is u minus half du. Then this guy will be minus half 18. This is u half plus c. It's minus 1 over 9 square root of 4 minus 9x squared. Okay. 32. Done. I better check my answer. Okay. I'm not sure. I hope no careless mistakes so far. So hope not. I'm actually double checking my answer key, but okay. So let's look at the next one, 33. So then after that, I've seen students struggling with this question here. Because of all the information overload, then they totally forgotten how to do this. This guy here is not, because this is linear, right? The key thing is this is linear. So basically, you just need to do, it's just a secondary school integral here. It's nothing more than just add 1 divided by half, then put a minus, divided by coefficient of x. So that's all. So this will be minus 2, 9, square root 1 minus 9x plus c. 33. Okay, that's that. So let's look at 34. 34 will be, now 34, how come it's oh minus, it looks the same, bro. Top is constant, bottom is quadratic. So this is 1 square minus 3x square dx. So straight out, just use your MF27. This is sine inverse 3x. Okay, this is the same thing. I'm gonna remember to divide it by 3 because now your u is 3x. Okay, so this is the one which every time I see students make a mistake when it comes to applying the coefficient divide. Because just to clarify, when you integrate 37x dx in secondary school, you do negative cosine 7x over 7 plus c. Then you say, how come you need to divide by 7? You will say it's chain rule, which is not wrong, which is true. But now you have a new perspective. If your u is 7x, similarly, now you put your u here. That's why you have an extra 7 there, you see. The 7 is here. Okay, so just understand, if a linear expression, you need to divide by the coefficient of x. Are we done with... Oh, then after that, the last one, which is 35. So 35 here, you have got this guy. Okay, this is slightly tricky, I think. So you can't invoke most of the things, like it's not quadratic, then it's rubbish. Basically, it's like you can't do much because... So what you need to do is understand, try by parts. Okay, just try by parts, because that by parts is just last resort. Then if Liate is concerned, if you have 2a, this is a and this is a. If you have 2a, you always choose the u. The u should be the one with the lowest positive integer, I think. So because then you differentiate, it'll be a constant fast. So say if 1 is power of 5, the other power of 2, you choose the u as a x squared. It's not wrong to choose a power of 5, but you just have to do by parts 5 times, which is not very welcoming. Okay, so yeah, let your u be x, then your dv dx be 1 minus 9x minus half. So this du dx will be 1, v will just be 1 minus 9x half minus 9. So then in this case it will be uv, my uv, so it will be, oh, maybe I just rearrange this one, minus 2 over 9 square root 1 minus 9x. This guy will be uv, so it's x minus 2 over 9 1 minus 9x minus of v du dx, which is minus 2 over 9 1 dx. Okay, I think that's it. This will be minus 2 over 9x plus 2 over 9 half dx minus 2 over 9. Okay, 1 minus 9x 3 over 2 minus 9 plus c. Cancel everything up. Okay, 4 over 3, negative 4 over 3, negative 4 over 3 square root 1 minus 9x to the power 3 plus c. This is question 35. But my answer is off from the answer key again, so I hope. x over r power of negative half. Means I have careless mistake. 2/3. 1 minus 9. Did I do something wrong? Hold on. X is u. Okay, I'm going to take a red pen. Plus 1 minus 9. Oh, wow. Okay. Minus 2 9 v du dx minus 9 plus 29. Oh my goodness, no, I cancelled wrongly. My goodness, this is careless. 2 over 9 times 2 divided by 3. Where's bad? 4 over 2 4. Here careless. 4 over 9 times 3 times 9, which is 243. Okay, looks more like it. So something is wrong. I do not know what is wrong. Wait. UV. This is question 35. Yeah, supposed to be about 1 over 9 in front. UV x differential x is 1. UV should be getting this one. Or is there a minus 9 in front? X UV plus 1. Correct, right? UV, bring it up, minus 1, integrating. U minus 1. Why is there extra 1 over 9? I'm missing a 1 over 9 in front, but I don't know why is there 1 over 9 in front. UV. Let me check. u is what x1 du dx. dv dx is plus 1. It's correct. Oh, yeah, it's correct. Why do I get the answer? Okay. So it seems like it's correct. Okay. This is the answer. Why is it an MS? Okay. My answer key is wrong again. Okay, let's look at part 35. 36. Oh wow. This oh my goodness. 36. Second 36 is where? Okay, 36. 36 is you have got x plus 2, 1 minus 8x minus 4x squared dx, right? So you have, is this, so you always examine, is this cancelling, because you don't know, right? So you just u equals to 1 minus 8x. You see if you can cancel the one on above nicely. If you can, then it'll be good. So obviously, is this a multiple? No, it's not, right? You see that? It's not. So this case here, what you need to do is use a split up method, right? So you just put this as such. So this would just be 1 minus 8x minus 4x squared dx. Then what you need to do is you just put the derivative of this guy, just minus 8x. So side-quest again, solve for the unknowns that you need. Okay. So this guy will be x plus 2 equals to a minus 8 minus 8x plus b. So this is minus 8a, x minus 8 plus a plus b. So minus 8a equals to 1, a equals to minus 1 over 8. Minus 8a plus b equals to 2. B equals to 2 plus 8a, which is actually 2 plus 8 minus 8, which is actually 1. Okay, that's that. So you can do that. Then once you're done, you be able to, let me just, okay, this is just negative over 8. Wait, negative 1 over 8 minus 8 minus 8x over 1 over u du. Okay, maybe I don't skip step here. You just do that. 1 minus 8x minus 4x squared plus 1 over 1 minus 8x minus 4x squared. Then what you do next is you just complete the square for this guy. Same thing, side quest. Complete the square, because you can't use what do you call it, MF27 without using complete the square. So this is minus 4 x squared plus 2 x minus 8. 1 minus 4, x plus 1 square minus 1 square. Then you will get 1 plus, so it's 5 minus 4x plus 1 square. Okay, that's that. So you can do that. Then split it up. This minus 8 minus 8x. This is square root u. du minus 8 minus 8x plus integration of 1 over square root 5 square. You can put a 2 in front. Square dx. Okay. Then this is 2x plus 2. So when you use your MF, so this guy is when you just remember is integrating. This is 1 over 1. So u minus u du. This is u half over half. It's 2 root u. Okay, so that's that. So here's minus half 2 square root u, which is actually 1 minus 8x minus 4x square. Plus this will be sine inverse from MF. Okay, so that's that. So this guy will be sine inverse 2x plus 1. Don't forget to divide by coefficient of x, which is half. So the answer should be negative 1/4. Okay, the half is usually a killer. So students will conveniently forgotten about the half there. There you go. This is the answer 2 root 5 minus 1 over, yeah. Okay, great. Let's look at 38. 37. 37 is okay also. 37, and we use a new page. 37 here. What we need is x over x squared plus 4x plus 7. Same thing. You can't. Can we factorize the? You can't. We can't really factorize the denominator, so we can't really use partial fraction, right? So you check. You can't. So what we need to do is then very simply just split it up. So it's a 2x plus 4 plus b. Okay, so you just differentiate this guy to get this guy. So side quest again. So we have x equals to a 2x plus 4 plus b. So 2ax plus 4a plus b is equals to x. So 2a is equals to 1, a equals to half. 4a plus b equals to 0 because there's nothing there. So this will be 2 plus b equals to 0. So b equals to minus half. Okay, so side quest done. What I have next is 2x plus 4 over x squared plus 4x plus 7 dx minus 2. I'm just going to complete the square on the fly. minus 2 squared plus 7 dx. Then this will be half ln x squared plus 4x plus 7. This will be x plus 2 squared 7 minus 4 will be 3. Square root 2 squared dx. So this will be tangent inverse. Half ln x squared plus 4x plus 7 minus 2. Tangent inverse. Okay, so 1, I will get 1 over root 2. 2 over a, or 1 over a. So 1 over root 3 tangent inverse. X plus 2 over root 3. Okay, that's it. That's what you get for this guy here. So then we look at, oh, thanks, Nat. All right. Thanks, Nat. So anyway, we look at the... I'm only at 37, bro. Shit. Why did I sign up for this? I don't know. Yes. Okay, 38, usually they will give you the substitute. So in our syllabus, it will give us a substitution. But if you are legendary, right, like if you know how to use substitution, you should be able to tell what is your integral, the substitute there. So 38, okay. 38 will be, they usually will give the u-substitution, like, but if you already know how to use u-substitute very well, you should be able to guess it out. So I will suggest you try not to think how do you actually guess a substitute here. Yeah, so try to be legend. Yes, okay. Anyway, here, so if you look at the what's it called, bro? They give us a substitute. So just be mindful, if they give us a substitute, right, you just use it. So du dx, we know that this is just half 1 over root x. So then you know that dx, right, dx is just given by 2 root x du. Okay, I know some schools don't allow you to do this. Then just erase it after this is okay. Like I said, these are all in university textbooks, okay? You find YouTube, anyone teaching at university, okay, it's okay. Like, erase it if your school don't allow it. But I'm not I'm just saying that any day I'll just take the school university textbook, okay? Yeah. So anyway, this is what you get. You get this guy. Then they give you the substitute, right? So this would be 2x over 1 plus x equals in du. Now take note, you are in a u world, means you should be integrated with respect to u. You shouldn't include your x in it, okay? So like I always say, mathematicians have issue with their x's because it is either u or x. Okay, so you pick the so u is x is equals to u square from here. So I'm gonna just replace this u square over 1 plus u square du. Then here, what you need to know is you need to do long division. Okay, do long division, but I'm a bit lazy, so I'm gonna use the juggling method here. So I just put a 0 pair 1 minus 1. Okay, then after that, what I can do is this is 2 1 minus 1 1 plus u square. So but if you're not familiar with this method, it's okay, just do long division. Okay, I'm not gonna explain so much. So then this is 2 u minus tangent inverse u plus c. Okay, so this is it. This is 38, right? So this will give us equals to 2. U is our root x, right? So root x minus tangent inverse root x plus c. Okay, easy game. All right, let's look at 39. Wow. How do we do 39? Okay, can. So 39. Yeah, this one not directly in our syllabus. But usually if it comes out in exam, they will have like the first part, then they'll ask you hence integrate and so on, right? Annoying, I know. But just practice. The idea is very simple. You so like I say, this one maybe you want to put a hard star there. Is not something is directly in the syllabus. They have to tell you. So what you need to do is just you just put x squared plus 4. The reason why you do this is because this part, you know that you can actually let it be dv dx. You can integrate this one, okay? Then you let it be your u. So it's a by parts thing because one part it's a by parts thing. This guy you can integrate using u substitution. This guy you can just use u. Okay, so this guy u equals x squared dv dx. X squared plus 4. Okay, so I'm gonna quickly do this. So v is equals to integration of x over square root u. Du is 2x. So this guy will be just half u minus half du. So this will be just half u half over half plus c. So this is square root x squared plus 4. Okay, so if you use the u-substitution method, your u should be this guy here. So maybe just v is equal to integration of x squared plus 4 dx. So I'm going to let my u be this. Okay, maybe there's a u here also. So maybe we let this be k. Okay, okay. So side quest. So this is my v, du dx is just 2x. Okay, great. Then what you do is you just use by parts. X squared. This is which question? 39. Yeah, x squared plus 4 minus of v u v du dx. So I'm gonna just put 2x and then square here. Yay, good job. Okay, then this guy obviously is another cancelling method. So I'm gonna let maybe I just let this be maybe k. I used k just now, so maybe I use this as p x squared plus 4. So this guy will be x squared. Oh, so this is integrating because you cancel this out, right? This integrating half p is just p 3 over 2 over 3 over 2 plus c. So I'm gonna just x squared plus 4 minus 2 third x squared plus 4 square root. I can put a root there if I want to. Then put 3 over 2. Okay, I'll put a root. Looks nicer. Okay, great. That's it. We look at the next one. Easy game. Oh, almost halfway there. Okay, 40 is not bad. 40 is easy. So e2x. So by now you should know how to use your u-substitution. So this is e2x. Then you just square root u du. This is 2e2x. Cancel it out. Easy game. Half u du. Half u 3 over 2 plus c. This guy will be 1/3 square root u to power 3. Okay. Of course, once you are familiar with the u-substitution, you can just skip step. Okay, I'm trying not to skip step so that you will follow me. Okay, let's look at the next one, which is 41. 41, where were we? The last time I checked. So, 41, okay. Wow, okay. Man, I don't know how long I can last. Okay, anyway, just 41. 41 will be same thing. Can we factorize the denominator? We can't, right? So if we can, then we just use by parts. But this case here is a very simple a 2x minus 2 plus b. Split it up. Then I'm gonna just solve this. A will be a 2x minus 2 plus b 2ax minus 2a plus b x minus 3 2a equals to 1, a equals to half minus 3 equals to minus 2a plus b. Okay, then this guy will be what? B will be, wow, b will be minus 3 plus 2a. That will be negative 3 over 2. Okay. No. Half. A is half, right? Sorry, I thought yes. So minus 2. 3a. A 41. Alright. 2a is 1 half. Minus 2 minus 3. Okay, great. So this will be half, then it will be 2x minus 2x squared minus 2x plus 4. So I think this one you should be proficient already. This is just complete the square, minus 1 square, which is like plus 3 dx. So I just complete the square out of a box. So then this will be half ln x squared minus 2x plus 4 minus 2 tangent inverse 1 over a. Okay, x minus 1 over root 3. Okay. Yes, no time to waste. Let's move on to the next one. 42. Okay, 42. Oh, 42 is also the same thing. Fun stuff. So how do we do it? And this one is oh shucks. What you do is you same thing, you need to manipulate it. So 1 plus 3x, right? So what we need to do is actually just multiply this with 1 plus 3x. 1 plus 3x. Okay, just manipulate lah. It's okay. Why? So that the top would just be no. It's 1 minus 3x squared. Okay, yeah. Sorry. So the whole idea is making the top. You want to root the top. I want to take the top. It's either 1 plus minus 3x or 1 plus 3x, but I multiply the top so that I could open a square root because I don't really care about the denominator. The denominator, I have my MF to help me. Okay. So this guy will be 1 square minus 3x square as such. So dx is a square minus b square. So then when I rearrange this will be 1 minus 3x square. Square root bottom will be 1 minus 3x square like that, right? Okay. The beautiful thing is the top will just be as such. So it become this guy here. Like that. Okay. Open it up. Then suddenly you can integrate this. Of course not directly. You need to split it up. Okay, so this split up will be quite clear in the sense that one side here is just use MF27. The other side here, you use 1 minus 9x squared. So, oh, sorry, this is x dx. Okay, then this one is just cancelling. Or rather, this is f prime of x. Then this is just MF27. Okay, that's it. So, always practice this kind of question before. That doesn't mean that you can't practice them. Okay, so just practice them. This is 42, right? So this is, remember this is sine inverse, 3x over 1. Divide by the coefficient of x. Oh, this one, I don't know how many times I need to repeat myself because, yeah, it's, no matter how hard I repeat, my students still do the same mistake. I see it's very painful. Part of me died. Oh my dear. U minus 18x. Cancel this out. This is quite okay, I think. Then you can side quite a bit. U minus half du is u half over half. So it's just 2 square root u. Okay. So this case here is not an issue. I think this will just be 1/3 sine inverse 3x. This will be 6, right? So it's a third. 1/6 times 2 is 1/3 square root 1 minus 9x squared plus c. This is question 42. Alright, good job. Okay, let's look at the next one. Next one. Same? Oh, wow. Okay. Okay, this is where the interesting part comes. Okay. Fun. Okay, come. Let's look at this. So sometimes students ask me how to do questions like this as well. So this is also quite challenging in the sense. Okay, now this is the fun part. So this one you need to combine like the cancelling method and also the like knowing what can be integrated and what cannot be integrated. So that's the idea there. So you will say you have to know this. Basically, whenever tangent square is concerned, tangent square is closely related to secant square. Then a lot of times students walk into the exam hall not knowing that this is not given in MF 27 or 26. So please understand that whenever you need to use this formula, I encourage you to just derive it. It's not very hard, but it saves life, right? Like that, just like that, okay? Then please understand that you can integrate this, but you can't integrate this. That's why this is the key. You can actually make life easier for you like that, okay? So that's that. How will I do? Oh, all right. So now, I will probably take one secant square x out. Then I replace this. Oh, there you go. Okay. This will be tangent square x. 1 plus tangent square x. Then this is secant square x dx. Okay. Then this is fun. Okay, so now you see this. This is a tangent. So I'm gonna let my u be equals to tangent x. You see that? Because if I let my u be tangent x, this is u square, then I can cancel the secant square in front. That's u, easy game. The secant square x. Then this guy du is secant square x. Cancel this out. So what is left behind would just be a very mundane integral that you learn in secondary school. This is u cubed over 3 plus u5 over 5 plus c. Okay, so this is 1/3 tangent cube x plus 1/5 tangent 5x plus c. Okay, so this is not easy, but it's worth a try. Okay, let's look at 44. Oh, 44 is the fun stuff also. Sorry. So too many fun stuff to do. Okay, so this guy, take note, is essentially somewhat the same. Actually, the same, I would say. It's the same as one of the question that we did, the EX that we need to rearrange, which is this guy here. Where's the guy? Come up. The EX one. This one. Okay, they sort of like, I think they are the same criteria, like, but this is a bit different. So you need to rearrange this guy so that it becomes something you can cancel as well. Okay, so one way, just like in complex number, okay, I think the J ones don't do that. The polar form, basically what we want to do is just multiply this e minus 5x. Okay, just multiply. This is the fastest way to do it. Okay, you technically see this as you have e10 here, so you have 10x. So you see the 1 as e0. So this is like 0x, right? The middle part is 5x. Alright, yeah. Okay. So you essentially want equal distance. You just want equal distance so that you can cancel. But usually this have to be what do you call it? They have to be like just nice, half of it. So if I want to multiply this in, this will be 10x e minus 5x. Then this will be e minus 5x. Then this will be, I need them all to be the same power. I power in the sense that I don't care if it's plus, I just same number, integer. So then this is 5x minus e minus 5x. E 5x plus e minus 5x, okay, dx. Then suddenly when I rearrange this, then this guy can be, this is my u, 5x plus e minus 5x. So du dx will be e 5x minus e minus 5x. This is e 5x5 minus 5e 5x. Cancel this out. Sorry, e minus 5x, yeah. So cancel this out. So 5 here. We get this 1 over 5. Right here, 1 over 5, 1 over u du. So this is 1 over 5 ln e5x plus e minus 5x plus c. What is this? 44. Yeah. Oh, something is wrong. Minus. Did I write wrongly? E10x, e minus 5x, 5x 5x e5x, differentiating 5x e5x. Doesn't tally with my final answer, so I'm checking. I think my answer here should be correct. But let me check. E to the power of should be correct lah. Minus e to the power of minus 5x. Then I have got e to the power of 5x plus. Okay. Okay. So obviously this is not the only way to integrate this. There are other ways to do it, but I think this is the, you can also split them up, not an issue. But I'm not gonna, you can actually split them up, but I'll just do this. Then we look at the, maybe I'll give an alternative solution to this. Ex e minus 5x. Okay, never mind. I think I'll just stick to okay, okay, let's look at the subsequent one. Subsequent one is 45 e sine square 2x sine 4x. Then this will just be like 1 plus e sine square 2x. Okay, so anyway, same thing, you let your u be this guy here. Okay, so for 45, you let your u be this guy here, because if you're, it seems complicated, but actually 1 plus e sine, maybe I just use it. 1 plus e sine 2x square. Du dx will just be e sine square 2x. Then you multiply the, you chain rule, right? You don't forget chain rule. You need to like bracket this out. So you start with 2 sine 2x. Differentiate sine will be cosine 2x times 2. Right, so this will be e sine square 2x. Then you have a 4. Oh, maybe not. This guy here will be your sine 4x. Right. It's just sine 2a is equals to 2 cosine a. Sine a. So a now is 2x. So this will be 2 here in front. So essentially what you get is u du e sine. This will be 2 sine 4x. Cancel this out. Then this will be half u minus half. So it's just half u half. Oh, just square root that value there. Just square root u, the entire thing. Okay. 45. No, not bad. 46. 46. 46. 46. B. This is by parts. E sine 2x. Why the 47 looks a bit weird? Okay. Okay. Right. 46 is obviously by parts. Tangent inverse 3x dx. Okay. The idea is u is our friend because u help us to take on difficult expression. So this is your inverse trigo. This is your algebra. So by latte, your u should be tangent inverse 3x. Okay. Then your dv dx is obviously just x. Nothing more than that. Okay, so there's that. So then du dx would just be 1 over 1 plus 3x squared times 3 is 3 over 1 plus 9x squared. V is just x squared over 2 integration. So what I'm going to do is just uv x squared over 2 tangent inverse 2x. Okay. Minus of v du dx 1 plus 9x squared dx. Then this guy obviously is 3x, sorry. This is 3x. It's just do a long division because it's improper fraction, right? So do a long division, be able to see the answer there. We will get this guy will be side quest x squared 9x squared plus 1 over 9 x squared plus 1 over 9 minus 1 over 9. Okay, so that's that. So then this guy will be x squared over 2 tangent inverse 3x minus 3 over 2 1 over 9 minus 1 over 9 1 over 1 plus 3x squared. I think the 1 over 9 can just be brought out because everything is 1 over 9, so x squared. One over 9. We 1 over 6, right? 3x squared. Okay. There will be half x squared, make it nicer. This would be 1 over 6. This would be x minus tangent inverse 3x over 1 divided by 3. Coefficient of x. Remember that, please. I cannot repeat myself. Yes. Remember the coefficient of x. Yeah, once you remember that, it should be quite okay. Right. That's the answer. Okay, we're going to reach the halfway mark. Very happy. Let me just look at the this is 46. Okay. We're gonna look at 47. 47 looks weird. Wow, 47. 47 we could integrate both ways. So okay, let me explain. So for 47, you have got x cosine x 3x squared e x squared dx. Okay, so similarly, You have to know that you can use cancelling method to integrate this. You can also, okay, so I'm a bit conflicted now. Latte. Okay. We could also, okay, we have two choices here. We can either use, we can integrate this, or we can let dv dx be this guy, or we can let dv dx be x cosine 3x squared, because both can be integrated. Then does it? Yeah, both can be integrated. So what will we do? X squared ex squared. We can try 3x. Let me see. Ex squared. Cosine 3x squared. $47. It's a 1/20 there. Oh, okay. Get it. Oh, wow. This is not easy. Okay, can. Okay, so you don't do by parts directly for this case here. Okay. This is a bit... Okay, this one I think is not really in syllabus, but we can try. Okay, so this is yeah, this is, you let your u equals to 3x squared. Then what we get is wow, cosine u du du, this will be 6x. Okay, down this makes sense, so cancel this out. What you get is this guy. Okay, then this is similar to what we've done previously, which is so it's a cancelling method nested in a by parts. Yeah, so it's similar to question 25 if you want to refer to whichever. But if this ever come out, it will be like part 1 and part 2. This is not directly in the syllabus, but same thing. You let your u be that so that you can cancel. So now you let your, I'm going to use by parts now. u1 is equals to latte, right? So u can be, usually we let it be cosine u. Then dv d1 that 1 dx du equals to negative sine u. This is u. Yeah, this guy 1/6 will be eu cosine u minus of sine u sine u u du. Okay. Maybe I could. Okay, maybe I just put this on. Okay, because it's very confusing. I think I was just gonna side quest the entire thing here. Okay, so it's not so confusing here. So we put a side quest here because this is infinite integral. We need it to be somewhere. So I'll use x instead. Yeah, that. U equals to ex. dv dx equals to cosine x. Liate, right? Negative sine x. And then v is equals to ex. This will be ex cosine x. uv minus plus ex sine x dx. Then same thing. You do the same for this guy. So u1 maybe this is a side quest. u1 equals to maybe sine x dv dx. I will just let it be ex again. Then du1 equals to dx, which is cosine x. v equals ex. This will be ex sine x minus of ex cosine x dx. Okay, so same thing. If you are part of the solution and part of the problem, please don't expand again because this will go on forever. So what we do is v du dx. Wait, differentiate cosine is okay. Differentiate sine is cosine. Okay. There you go. This will be ex over half. Okay, there you go. So this case here, because I side quest, so you see this entire thing here as your I. I'm just gonna side quest. This is I. This is your I. And this will be a 2i. Okay, then this is this. Okay, then you just plus a c lah. Okay. So I side quest here, so I'm gonna just plug my value in. This will be here from 1. So we do 2. This would be u is what? U is 3x squared. 3x squared. But how come I'm going to get? U, is it half? Crap. Oh my goodness. I did a mistake. Oh, painful mistake. Oh, crap. Okay, I need to fix it. Okay, I didn't pay attention to that. Okay, I paid mistake. This question here, let me just fix it. Okay, oh, this question is good. Got me. This is which question? 47. Okay. This is x squared. This is not 3x squared. So this is u over 3. Oh my goodness, I died. The u over 3. So I need to change this to u over 3. 3 u over 3. Okay, there's a lot of painful mistake there. But try. U over 3. Ex squared u over 3. So this is u over 3. Oh, I need to fix this. U over 3. Divided by 1/3, right? Then this will be uv 3 minus v du dx. U over 3, 1/3 will be 3. Be 3. Wow. Very painful. Very painful. Very painful. Very painful. Very painful. Okay, let me just change all these to 3 first. Then I have u over 3 here. uv. Oh my goodness, so painful. This times this. 3. 3. Yeah. That looks more promising. So then I will have 3. Yeah, I'll just change from here. Better. 3e x over 3 cosine x e3x sine x minus 9. Okay, job. I don't know who put this in. One of my tutor probably put this answer inside one of the teachers probably put in the answer inside this part. I think it's a good question, so let's try. Okay. Then this will be 10 ex over 3 cosine x dx equals to 3. Okay, then I get the answer. So cosine x plus 3 sine x. My goodness, I just died, man. Yeah, here. So I fixed the careless mistake there. Then I'm gonna just put 1 from 1. I get e 3 over 10. So this is u, right? U over 3. So all my x I changed to u. So u over 3. Then cosine u and 3u. Okay. Yeah. Then I get 1 over 20 then. 3 divided by this way to 1 over 20. EU about 3 will be, that will be x squared. U is, so is x squared. Cosine 3x squared plus 3 sine 3x squared. Okay, so this is definitely not in your syllabus. If they were not directly in your syllabus, but so you'll be like part 1, part 2, part 3. So don't get too upset about this, but it's good for challenge. So that's the how you do cancelling method, right? So that's that. 3x squared. Yeah. Oh my goodness, that is. Oh, okay. So 48 is quite okay. I think 48. Sorry. So 48. 48 will be Hi Johan. I don't know. I just saw a message. Hi Natanya. But I don't know. No, I just saw a message also. I'm halfway there. So 48. Sometimes students get tough, like don't know what to do. This one is just a very simple cancelling. So you just u1 cosine x. So du dx would just be negative sine x. Okay. So but you just ln so just this is sine x. Negative 1 over u du. So negative ln 1 plus cosine x plus c. Okay. 48. 48. Answer is different, no? Answer for 48 is also wrong. Or negative. This is what? This is 48. Okay, good. Alright. 48 will be that. I think 48, the solution probably use another form to write. Yeah, but anyway, 49. 49 is what? 49 is by also. 49, what you need to do is just by parts. Right, 49. You have got, this is a standard by parts. So you add a 1 in front. Okay. You let this be your dvdx. This is your u. Okay. There you go. So basically what you can do is u is equals to... The reason why we let this be u is because all the expression we learned so far, we all can differentiate, right? So everything can be differentiated, but not everything can be integrated. So that's why u is our saving grace. So when you do this, you just take your method is at 7. Then you check the integral of what do you call it? The integral of sine inverse. Okay. So integral of sine inverse is the derivative of sine inverse. So it's 1 minus x squared. So 1 minus x squared. So just do that. So this is like du dx. 1 minus 3x squared times 3. V just x. Integrating that. So then this case here, what is uv minus v du dx. So 3v this one is obviously cancelling method, so you can cancel the one on top. So this guy will just be x sine inverse 3x minus 3x over 1 over u du minus 18x to 6. Cancel, right? Minus half du. This case here will be u half over half is 1/3. $49. X sine inverse 3x 1/3. Yeah, correct. Answer is correct. Let's look at 50. Halfway there. 50 will be x sine 3x squared plus 1 dx. What you do is you just let u equals to 3x squared plus 1. Is x. You can cancel, right? Just cancel the one in front. So x sine u du 6x. Cancel it out. Then this will be 1/6 sine inverse sine u du, which is negative 1/6 cosine 3x squared plus 1 plus c. Okay, that's about it. So cancelling method. So get the subsequent one, which is 51, which is by parts. Obviously, it's by parts, right? So 51, if you do 51, will be x sine inverse this is 2x dx. So u will just be x. dv dx. Oh wait, sorry. I'm not thinking straight. I got the x there. If I let my u be sine inverse, yeah, okay. U be sine inverse, it has to be, because this is inverse trigo. dv dx will just be x. Okay. So then your du dx, use your MF26. So MF27 says that integral is minus the derivative. So it's 1 over 1 minus 2x squared. Multiply by, oh my goodness, there's a chain rule here. So outer layer, then inner layer. So this guy inside will be minus 2 over x squared. Then v will just be x squared over 2. Okay. So this guy will be uv, which is x squared over 2, sine inverse 2 over x. This is 51, right? Okay, sine inverse 2 x, then plus, oh no, sorry, minus v du dx. So minus of v du dx, which is this guy here, which is I can just put a plus because it's negative. Oh wow, interesting. So this is half x squared sine inverse 2x plus cancel, right? Cancel. Love it. Then this will be x squared minus 4 over x squared dx. Bring it up. Oh. Plus this will be square root x, square root, this will be this, right? Okay, so you let this be your u, cancel. It's cancelling method. So this one, I'll just side cross so that k be x squared minus 4. So x over square root k will just be dk over 2x. I cause I'm lazy to write everything out again. So k minus half dk. This is k half over half. So this is just k about half. Okay. So this guy here, get half x squared sine inverse 2x plus k, which is like k is our x squared minus 4. So square root x squared minus 4 plus c. Question 51. Yes, answer is correct. Let's look at question 52. How to do? Oh wow, interesting. Okay, let's do that. So for 52, what do you do? Okay. 52 is important to understand. If bottom can be factorized, factorize it, because you can't cancel. There's no way you can, like algebraic fraction, if you can factorize, you just factorize it. Okay, it's not this one over here. Factorize it. So this is actually x for x squared. So it's not rocket science to know that this is like x squared plus 1, the difference square. So further simplify this to, okay, this same thing. This question is not directly in the syllabus. So what they will do is they will ask you for first part to do this portion here. So x squared minus x minus 1, x plus 2. Okay, then from here, what do you do is that you, what do you call it? You just express lah. This is x minus 1, x plus 1, x squared plus 1, right? Equals to 1 over x minus 1 plus 1 over x plus 1. Is okay. Then c x plus d. Okay, that's that. So just find all the individual term. I think the one which is the problem is the cx plus d. So this one just find e x minus 1, x plus 1. Okay, so for a, just x equals to 1, a will be 1 over 2 plus 1, x equals to minus 1, x equals to 0. Wow. It's not fun. Zero, we get the d. So this will be d would just be minus d, negative d. 1, 0. I'm just looking at the, so half, 1 quarter plus 1 quarter is half. Then half minus d is equals to half. D is equals to minus half. Okay. Then for my c, I can just replace any value I want. So minus half. So I can just let x equals to 2, I guess. Or is it compare coefficient? Could I? I could. Oh, okay. I could. Is it easier? X cubed. Highest degree is x cubed. X squared. Oh, okay. Compare coefficient of x cubed. Be coefficient of x cubed. Maybe be 0. This is a plus b plus c. So c equals to minus a minus b minus 1 quarter minus 1 quarter, which is 0. So c is 0. Wow, so much for the, so this a will be 1 quarter, b will be 1 quarter, d would be minus half, x squared plus 1. I think the one that takes a lot of time is just by partial fraction. Then this guy will be negative 4 ln x minus 1. Tangent inverse x. Don't really need to factorize the 1 quarter out, right? Yeah, that's it. X. Oh, minus. That's right, this is minus. Minus 1. Yeah, that's correct. That's it. Part 52. Let's look at, 53. Not easy also, but let's look at 53. 53, not directly in syllabus also, but you will see in your school exams, I think. Okay. The trick here is very simple. It's actually, you just see this very carefully, is that this is 1 over root x, and then you always understand that when it's 1 over root x, you try to let your u be root x, okay? Because if u is root x, basically what I'm saying is you can just apply a root and square here. Because if it's root x, this root x can cancel the 1 over root x in front. So that's the main thing. You want to, this is 1 plus u square. Du half. So then this will be cancelled away. cancel away. So that will be a tangent inverse. Just a classic tangent inverse here. So it's 2 tangent inverse u plus c, 2 tangent inverse square root x plus c. Okay, so it's 53. 2 tangent, yeah, can. So let's look at the subsequent one. Let me go and grab water. Okay, let's look at 54. Oh, using substitution. I think it was okay. Using substitution, like, so generally when for substitution, okay, 54. Just dry my hand. For 54, what you need to understand is actually you they will give you the substitution. So don't confuse actually they're the same thing. So they will give you a substitution, like let's say x equals to cosine u. So this is no longer like you put a du, then you just put a derivative again. So that's the thing. So dx du will just be, just understand dx du, just be negative sine u. Okay, so dx will just be negative sine u du. Okay, like I say, all these things, yeah, I know some schools don't allow, then just erase it, okay? Just erase it, is fine. So this will just be x cubed. Like I say, like all these things are not, these are all in university textbooks. So I'm not here to argue who is right or who is wrong, okay? But I'm just saying that, like, if it's written in the lectures, in university lectures, probably I don't want to go and say it's wrong. But if your school don't allow, just erase, okay? There's no big deal. So anyway, this dx, you change it to this guy already. Then this x, you just replace it in, okay? So I'm not gonna, so cosine cube u, 1 minus cosine square u, the sine u here, du. Okay, so the thing is then, this guy, remember this is like cosine square a plus sine square a. This formula obviously is not hard to remember. So you just change this to sine square u, cosine cube u, this is sine square u, this is sine u, du. Cancel this out. This can be cancelled out. Oh wow, left with, ouch. How to integrate this, right? Oh my goodness. Oh, yes. How? Okay, it's fine. What? Let's see, 50. Okay, how do you integrate this? Okay, let me explain. Okay, if This case, when you reach this juncture here, this is a very common. This is not in H2 math syllabus, but it happens in school exam. So, but what you need to understand is the idea is if cosine u is odd power, you let your substitute k. I'm using cancelling method. Okay, maybe I use u1. Okay, this one just came out in some of the school exams. So I think it's very very different. Okay, so if it's odd power, you let I don't remember if it's sine u or sine u cancel off. Or you let it be sine u so that you can cancel off the cosine. Then you can just use, okay, let me explain. So if I let this be u1, I'm using cancelling method now. So it's -1 cosine cube u du1. Now actually u to du1, so this is sine u. Maybe I don't that u1. I let this be k lah. Okay, so that it's not hard to see. Sine u. I mean, it's more dk du would just be cosine u. So cosine u here. Okay, so I cancel this guy. So what is left is actually negative cosine square u dk. Okay, now the thing is, this is a k, this is u, right? You want to change to in terms of, so you change to, this is sine u, so minus sine square u dk. Why? Because this using the unity formula here. So this will be 1 minus sine k square dk. This will be just minus easier k minus k cube over cube plus c minus k. K is sine u square. What is sine u, bro? Okay, great. Sine u is, you need to change it to x. How to change it to x? Changing back to x will mean that you use the right angle triangle. So this guy will be just u. Then u, this is adjacent over hypo, so it's 1 minus x square root. So sine u will just be 1 minus x square. Okay, sine u. Then that will be your 1 minus x square. About 3. Yeah, that's how we do this question here. Okay, professionally. Not easy, but okay, that's what. So let's get 55. 55 is the same thing, infinite integral. So I think nothing special there. We did it just now. So it's let u, doesn't matter which cosine ex actually. I mean, let u be cosine 2x and my dv dx just be e3x, right? So du dx will just be -2 sine 2x. V will just be a third of e3x. Okay. Then this case here will just be uv, so it's 1/3 cosine 2x. Cosine 2x ex. Sorry, I should just erase this. e3x cosine 2x minus of plus 2/3 e3x sine 2x dx. Okay, then u1 is obviously sine 2x dv dx is the same thing. Change it e3x. So du1 dx will just be 2 cosine 2x. V is just 1/3 of e3x. Similarly, so just do that. 3x cosine 2x plus 2/3. 1/3 e3x sine 2x minus of 2/3 e3x cosine 2x. Same thing. This is where I say if you're part of the problem and part of the solution, confirm you're the problem. So this as I, this like we usually like to let this be I lah. Okay, it doesn't matter. You want to be whatever. You see this as entity here. So you just let I be that guy. So I is equals to 1/3 of E, 3x cosine x, 2x. Oh, this is 2/9. X sine 2x minus of 4/9 I. Yeah, so that's that. So this is this I. Let me see any careless mistake for 2/9. That'll be 1 plus, is it 13/9? So it's 13/9 I. Bring out the EX. Maybe bring out the 2/9 E3X will be easy. Be good. So think 3/2. 3/2. Now take out 1/9. 3 cosine 2x plus 2 sine 2x. So hence I will be 1/13. 3 cosine 2. Yeah, good. So that will be, you just make I the subject. That will be your integral. So divide. This is 1/13. E3x, 3 cosine 2x plus 2 sine 2x plus c. Okay, that's that. 55 done. Oh my天, 56. Oh, okay, 57 will be quite okay. So let's go at 56. 56 will be this 1 plus x square dx. Using a substitution, x is equals to tangent u. So dx du secant square u. Okay, so you make dx the subject, you can just multiply and then substitute in. Okay, so 1 plus tangent square u. Okay, like I said, it's just, I know some schools will allow erase it after you just, okay, like I said, like if your teacher is really against it, ask them to make a YouTube channel and just explain, okay? But everyone is, I had nothing to say. I'm just okay, peace, bro, peace. I if you don't like, then just erase. It's okay. It's nothing inherently wrong. But if your teacher insists it's wrong, then just erase. So dx is this guy, secant u 1 plus. Okay, so this guy here, everything change. So remember, 1 plus tangent square is secant square. Okay, so you just change it to that formula that you have. So always, whenever you need to use it, you don't remember, always learn how to derive, because it's not part of the sine over cosine square. Okay, so this is tangent square a plus 1 equals to secant square. So this guy will be secant square u. Okay, cube, then is secant square u du. Cancel it out, just be 1/secant square u du. Cancel, right? This will be cosine square u du. So then what you need to do is just use a double angle formula. Cosine 2a is equals to 2 cosine square a minus 1. Cosine square a, cosine 2a plus 1 half. Okay, then you just half cosine 2u plus 1 du. Okay, so then this guy will be just half sine 2u over 2 plus u. See, then replace back your u. Tangent u was x. Draw the right angle triangle. Tangent to u. So tangent to u is actually just 2 sine u cosine u over 2 plus u plus c. Draw it out. You have got u here. Then you have x over 1. Then this is x squared plus 1 squared over 1. Same thing. Cosine u will just be 1/1 plus x squared. Tangent sine u will just be x over 1 plus x squared. Okay, then this guy will just be sine u multiplied by cosine u. Then your u will just be tangent inverse x. There you go. Then you can this will be answer, hopefully. Ta-da. Need to change back to x, okay. This is question 56. Yeah. Okay, so I think subsequently the question 57. 57 is 57 is also, like I said, I think not directly, this is not directly in the syllabus, but because it doesn't matter, maybe in the syllabus, because syllabus for f from fx, there's only 2 lines in the exam, but it's okay. So u is equals to tangent inverse, because you can cancel off the 1 over, so this is 1 over 1 plus x squared, eu du 1 over 1 plus x squared. Okay, cancel it off, life is good. You get is eu plus c, so this will just be e tangent inverse x plus c. 57, done. Let's look at 58. 58 will be, okay, 58, right. 58 is also cancelling method, so like I said, you have to be able to tell. Hey, is this repeat? I don't know if this is repeat. This is the same. I thought I solved it just now. Oh, it's different. Okay, it's the same. It's same as question 14. Yep, okay, this is the same as 14. Sorry, there's a repeat here. I didn't see that. Repeat. It's okay. We do it. So it's a repeat, same as question 14. So the u is just root x. But c equals to minus 2e minus. Okay, there you go. Then look at 59. 59 is the same thing, it's cancelling. So you have to develop a knack of knowing that differentiating ln will just be 1 over x, right? So this guy can cancel the 1 in front, so this is 1 over x. 1 over u. U is just 1 minus ln x. Then du will just be minus 1 over x. So we cancel it out. This will just be minus 1 over u du. So this will be minus ln u plus c. This is minus, sorry, this is about 5. 5. This is u minus 5. So this is u minus 4 over minus 4 plus c 1 over 4 minus ln x over 4 plus c. Okay, 59, done. Then what do you do next? 59. $60. So remember, anything which I didn't star means they are directly in your syllabus. So don't anything which I say not directly, so it's just for exposure's sake. So 60 root x. Oh, this is interesting. Okay, sometimes they can be what we can do is instead give you this expression here. So like say if give you root x minus x dx, how to integrate this? It may look confusing, but you need to just rearrange it as such so that everything root x, you just try to get the root x out, okay? Like that. So this is 1 minus root x. So this is my u du. So this is just minus half 1 over root x. Cancel it out. There will be minus 2 ln 1 minus root x. Okay, so I'm not gonna. That's that. Okay. Then 61, how? 61, yeah, so 61 is the one which is where you can actually concretize the concept here. So you let u equals to root x. Okay, this one actually exam questions comes out. So just understand that this could be your u. Oh, sorry, the entire thing. It can be root x or 1 minus root x. Yeah. So this will be root x 1 over u. Okay. So this will be half minus 1 over root x. Cancel it out. So this will be minus 2 u minus half du. This minus 2 u half over 2 plus c minus 4 square root 1 minus root x plus c. 61. Okay. So I do it. So you look at 62. Nice, 62. 62 looks confusing, but it's not. So by now, you should know 62. When you see tangent square, tangent, you should know secant square is closely related to tangent. Okay, so you try and rearrange. So that's why what do you call it? A trigo integration can be difficult because you do not know whether you need to use trigo identities to change any of the 8 expression which you can integrate, or you just use cancelling method. So oftentimes it's a lack of exposure. So this is your u. So this is secant square x u du. Then this is secant square x. Cancel it out. U minus half du. So you can just u half plus c. So you can skip that step over there. Okay, I'm just writing this down so you know. 62 done. 62, yeah. 63, let's go 63. Oh, wow. Okay, let's do it. 63. 63 is a nice trigo. So we have tangent 7 2x plus tangent 5 2x dx. Okay. So what you do is you just put tangent 5 2x. Then you just put tangent square 2x. I don't know. I'm just factorizing it now because there you go. So you know this guy is secant 2x. So remember, I said that this formula is not given MF26. So always derive it. Okay, so divide as x. No, but if I know how to derive it rather, because if you have to know how to derive it because it's not given MF26. If you can work it out in your brain, then you obviously don't need to. But I keep needing to write it down because the problem is always students don't know how to draw this. So this is secant square 2x. So that would be my u, would be my tangent, right? Dx. So my u is my tangent 2x. So this guy will be just u5 secant 2x du. Secant square 2x times 2. Okay. My handwriting is getting worse because I want the last few. I think you don't need a lot of explanation because for this juncture you should know what I'm talking. So this is 1 over 12 tangent to the power of 6. So tangent to the power of 6 2x plus c. 63. Done. 64. Oh wow. Okay, good. Okay, this stretch is interesting really. It gets more interesting. So this stretch here. Here is all the trigo trigo bosses that you have to have to know how to do it. Okay, so I think just keep in mind, for example, you know that sine, you can integrate sine a. How about sine square a? How to integrate? Sine cube a? How to integrate? Sine to the power 4a? How to integrate? Okay, and so on. So these are all the expressions here you need to know how to integrate and differentiate. Okay, let me see. Okay, I think hopefully I can finish them soon. So number 64, how we do it? Okay, 64. So now you're talking about cosine 4x dx. Huh? So remember, we could actually anything. Okay, if it's 4, you think about this one, we can't integrate. So basically we can only integrate directly the 4 expression here, which is the sine, cosine, secant square, cosecant square, tangent, cot. So by any means necessary, change it to these forms here. Okay, because these are only 8 expression you can directly integrate. So it's not cancelling method, so then you have to change it. So that's why we consider that. Then the other thing is also we have to understand is cosine 2a is equals to cosine 2a. This is M26. Cosine 2a minus 1. The good thing is that this expression here, you can reduce the power of 2 into 1. So if you can reduce power of 2 into 1, because you can't integrate this guy, but what you can integrate is this 2 guy. Meaning, by right, you can also reduce the power of 4 to 2 to 1, right? So this is power of 4 here. So don't worry, what you do is just put cosine square x here and square dx. So this guy will be cosine 2a equals to cosine 2a plus 1 over 2. So we have half, and then we got cosine 2x. Yeah. Plus 1 square dx. Then what we're going to do is just slowly expand it. So it's cosine square 2x plus 2, cosine 2x plus 1 dx. Just expand as usual. The half square will be 1/4 in front. Then this guy, same thing. You use this power, this one, reduce it to one single power. Now the good thing is we can integrate this and can integrate this, right? So we have to worry about this cosine square here. So this will 1/4 4. Then this will be half cosine 4a. Because if a is 2x, we get cosine 4x plus 1. Let's do cosine 2x plus 1. So that's the idea there. The idea of 4x. So I just 3 over 2 dx. Okay, there you go. Ta-da! Integrate this guy. This guy is nothing more than just a secondary school integral. So I'm just gonna simplify them. So sine. Okay, that's it. 64. All right. Okay, that's it. Then we're gonna look at the next one. 65. 65, we have got sine. So it's the same thing. So I usually tell my students is that if you have to choose one trig identity to be special, it has to be cosine 2a, because cosine 2a is very useful in terms of the only one with 3 different equations, right? So this could be, you can also reduce this guy here to a degree of 1, which is helpful. So we can't integrate this, but we can integrate this, both of these. So the idea is change it. Sine 2a, 1 minus cosine 2a divided by 2. This would then be sine square x square dx. This is just what we get is 1 minus cosine 2x over 2 square dx. Okay, then same thing. Express everything out. Then I'm going to do it quickly for obvious reason. So if you have any problem, just let me know. Then this guy is good to go because we can integrate this guy. Okay. Amen. Okay. So then after that, we use the same thing, which is cosine 2a equals to 2 cosine square a minus 1. So cosine square a is equals to cosine 2a plus 1 over 2. So then we just gonna here 1 minus 2 cosine 2x plus half cosine a is 2x. So this is 4x plus 1 dx. Okay, then entire thing here is nothing more than what we can do in secondary school, the integral here. So 4 3 over 2x minus of sine 2x plus 1 over 8 sine 4x plus c. 3 over 8. Okay, wait. Okay, that's it. Then we're going to look at question 66. 66 is secant cube. Here come. So 66, where we have secant cube, how would you do it? 66 is secant cube. So oftentimes when it's secant square secant, you have to use this formula here, bro. You cannot go about not using this. So the 1 plus tangent square a is equals, so know how to derive it. I'm not going to keep writing this out, but idea is this. So we need to just secant x, then secant square x dx. This guy will just be secant x, and then 1 plus tangent square a. Sorry, x dx. Then this guy here and that guy there, express it in. Okay, this guy is in mm27. Okay, so just understand, you don't need to memorize it because it's given in the mm27. So secant x is ln secant x plus tangent x. So you just use, so understand the expression you can integrate. Then the second guy here is just use u-substitution, cancelling. Okay, this guy is called cancelling. Okay, cancel it. Cancel. U-substitution. So anyway, I'm gonna just separate them up. So secant x dx. Secant x. Something is wrong. Did I go wrongly? Secant x tangent x. Wait, my tangent cannot cancel secant. Hold on. Secant. Wrong. I cancel. Secant square. I use cosine. This secant, differentiating secant with secant tangent. Wait I explain only secant x is tangent x. Secant tangent, I can cancel the tangent. Oh, okay. Gotcha. Secant I can integrate. So this is not cancelling, sorry. Secant. Maybe we just try and change it. Sine square, cosine square. One plus tangent secant square. Secant cube, Can you use by parts? Secant cube. Wait lah. Cosine. Cosine, I get cosine cube. Cosine cube cancel. Reduction. This side is okay. It's a secant x tangent x square, which is a problem. I let my secant x be secant x tangent x. Secant x tangent x, secant x tangent x. Wait lah. My u is okay. Wow, okay. I see. Oh, okay, I don't know. Okay. Okay, so this part here. Okay, so the thing is, I'm not sure if this is the only way to do it. Okay, but because we can't use cancelling method, but this guy is from MF27. Okay, or maybe this, I don't know whether if exam come out, this will be separate parts, but this is an interesting one. So what I'm going to do is essentially I let u be this guy. This is my dvdx. The reason why I let this be dvdx is because from MF27, I know that I could integrate this guy. Okay, integrate this guy, get secant. So essentially, you get, I'm going to write this down. dvdx. I do by parts. Secant x tangent x. So this is secant x, okay, from MF26. So du dx will be secant square x. So this will be from MF27. I keep needing to refer to it on my website here. So this will be secant, integrating secant x will be ln secant x plus tangent x, right? Plus uv secant x tangent x oh wow, minus of secant cube x dx. Mother secant square secant x dx. So it's the same thing as the thing that we mentioned. If you're part of the problem, you're also part of the solution. then you have the problem. So this is secant cube x dx. I'm not sure there's an other way to integrate this thing. If you think that there's a way, let me know. The secant cube x dx. So this is cube. Okay, then this guy will be 2 secant cube x dx. This is interesting. X tangent x. Then what we're gonna do is just I think if exam were to come out, this will be also some parts they will just careful for you. But it's good to just think and solve. Okay, so then that's it. Okay, great. So there you go. So get in that subsequent one. Okay, let's look at the next one. Wow. This is 66. 67. 67, you have secant 4 to the power of 67, you have secant 4 to the power secant to the power 4x dx. So same thing, you oftentimes need this guy here. Okay, so see how you can, so secant square x, then I've got secant square x here. So what you do is using cancelling method. This is 1 plus tangent x. This is easier. You let your u be tangent x because tangent x can cancel out secant x, so it's good job. Secant square x. 1 plus u square du. Secant square x. Okay. So this guy will be cancel it out. So be u plus u cubed over 3 plus c tangent x. Tangent cube x plus c. Okay, great. Let's look at 68. 68. 68, you have tangent to the power of 4. 68 tangent by 4, so this will be tangent 4 3x dx. Tangent 4 3x. Same thing. I'll suggest is you change it. So because now it seems like you can't really, then I put this as tangent square 3x. Then I know 1 plus tangent square a is secant square a. So this guy will be 1 secant square 3x minus 1 tangent square 3x dx. So this case, okay, this is quite okay. So you have got secant square 3x. Expand it in. This guy can use cancelling. This guy just change to secant square a. You change. That's about it. So this will be secant square 3x. Do you let your u be your tangent? Secant square 3x 3 minus of tangent change to secant square 3x minus 1 dx, because you can integrate secant square. Okay, you can integrate secant square, but you cannot integrate tangent. So this cancel away, will be 1/3. This will be u cubed. Cancel this guy. So I never skip step here. There's tangent 3x over 3 minus x. U cubed over 3, so it's 1/9. U is tangent Okay, 68 done. 69. 69 will be sine cube 2x minus 1 dx. Oh, okay. So this case is where you need to use what do you call it? The 68, 69, and 70 is the one where if it's even power, odd power, you let your u be the other way, right? So like let's say this is odd power. What I need to do is sine x, sine 2 power 3. I let this be cosine 2x minus 1. Okay. This is strictly speaking not really in the syllabus, but it comes out in exam. So I think it's not in the syllabus outline, unless okay, if it ever come out, it won't be directly, it will be like scaffolded also. So this one, differentiate cosine, will give you -2 sine 2x minus 1. Okay, so then will be minus half. This is sine square 2x minus 1 du. So don't forget this is minus 1. This is 1 minus cosine squared. Because we're in the u world, we need to, we're integrating with respect to u. So we change to u. So this is 1 minus u. 1 minus u squared du. Okay, so there you go. So this is 1 u minus u cubed over 3 plus c. Then this guy would just be minus half cosine 2x minus 1 minus of 1/3 cosine cube 2x minus 1 plus c. Okay, that's about it. 69, that's how you do it. -2 So for 70, same thing. Like I said, it's not really in the syllabus, so but comes out in school exam paper, so might as well. So usually if it comes out, it will be scaffolded. So you let u be sine 1 my goal is to make this an even power. That's all I want to do, right? I don't remember what to substitute, but I just know that I need to somehow reduce it. So differentiate sine will be cosine 1 minus x, then you put a minus here. Cancel this out. Then this will be 2. This guy will be just minus cosine square 1 minus x. So now you're in the u world. Change it to, so this is 1 minus sine square 1 minus x du 1 minus u square du. So this is 1 u minus u cubed over 3 plus c. Then this is minus sine u plus 1/3 sine cube 1 minus x plus c. Okay, so that's how I do question 70. Question 71, same thing. You just want this to be even powered, so you just let your u be sine 4x. Okay, that's all I know. So cosine cube, because we can leverage on the sine square a cosine square a equals to 1 formula. So it's u8 lah. If you want to think about it, it's du 4 cosine 4x. So you cancel this out. Maybe 2. This guy will be cosine 1/4 cosine square 4x cosine square 4x u8 du. Then this will be 1 over 4 cosine square 4x is just 1 minus sine square 4x u8 du. So if I were to simplify this, this would just be 1 minus u square u8 du. 1 quarter u8 minus u10 du. 1 quarter u9 over 9 minus u11 over 11 plus c. That's the answer. Yeah, so 1 quarter sine 9 4x over 9 minus sine 11 4x over 11 plus c. 71. Done. Okay. Let's look at 72. 72 is, so all the trigos we done. Okay. Okay, now back to algebra. Then I think the last few should be quite fast. We have to see. Okay. All right. 72. Okay, so let me look at how many pages I have here. Okay, but anyway, 72. 72. What I feel is we need 1 plus x over 2 minus x squared. So you check it whether you need to whether you can use cancelling method. Okay, obviously you differentiate this will be minus 1 minus 2x. We can't cancel the one top, so you just need to use the split up. So you split it up, it's quite easy. You just do this up. Okay, the idea is just one side you're using cancelling, the other side just use m26. Easy game. So this guy will be minus 1 minus 2x. Okay, so when you solve this guy out, so this guy, a minus 1 minus 2x plus b equals to x plus 1. So minus 2a equals to 1, a equals to minus half, minus a plus b equals to 1, b equals to 1 plus a half. Okay, so then what we get is very simple. Half minus 1 minus 2x. Strictly speaking, the splitting up method will also be scaffolded. Okay, so you don't really, but I mean, it's good to just know, yeah, but it's okay. This is like that. 2 minus x squared dx. Then you complete the square for this guy. Okay, then this guy you just use your cancelling. So this guy is just cancelling a, let u equals to 2 minus x squared. This guy will just be half minus 1 minus 2x. U du minus 1 minus 2x. Cancel off this one. The other one, just side quest. Minus x squared minus x plus 2. Minus x plus 2. X plus half x squared. Okay, so I'll just complete the square here. So 1 quarter plus 2 is 5 over 1 quarter plus 2 is 5 over 4. 9 over 4. 9 over 4. One quarter, so minus x. So just side quest in terms of the what do you call it? The completed square. So this guy will be plus, right? Then there'll be 9 over, okay, maybe square root 3 over jalat. This is 3 over 2 square. X plus 12 square dx. Great. Okay, so this is half. This is u minus half du. This would be your sine inverse. Okay, so you just look at this guy here. MF, this guy. Sine inverse x over a square. Yes, sine inverse x plus over 2 over 3 over 2. Question 72. So this guy will be plus half. So this is square root u. If you integrate this square root u, so it's 2 minus x squared. This will be half sine inverse 2x plus 1 over 3 plus c. Okay, so I basically just multiply by 2 here. That's all. Right, that's not too bad. So 73. Just go on. I don't know how long. I don't dare to check how long is the stream. I just bulldoze my way through the 100 integral. 73. It's also a split up. Can we factorize? We can't factorize the denominator. We can't. Yeah, so 73 is also another typical question. So 73, what we need to do is to 4x minus 1, that will be x squared plus 2x plus 3 dx, right? That will be a, you go through the series sequence, right? So you don't straight go to split up. You have to think like, is it cancel? It's not cancelling, obviously. So then you just split it up. Like that. Yeah. So this guy, what happens is you get 2x plus 2. Just differentiate this guy in. Then side quest the a and b and see if we can solve for the a and b. Shouldn't be an issue. Should be quite fast. So 4x minus 1 equals to a. 2x plus 2 plus b. 2a equals to 4. A equals to 2. 2a plus b equals to minus 1. B equals to 1 minus 2a minus 3. Yes, negative 3. So then what I'll get is actually just 2x plus 2, x squared plus 2x plus 3 dx. Then I'm gonna just negative 3 here. Complete the square. Here's tangent inverse, 1 over a and so on. This is question 73. Is something wrong? Oh, it's minus 1, my goodness. Sorry. It's minus 1. Minus 1. Minus 4, minus 5. Negative 5. Okay, minus 5. About it. Then this guy will be just square root 2. Then you just do ln 2x plus 3. It's almost second nature already. Once you know how to do it, it's not that hard actually. This will be x plus 1 over square root 2 plus c. So 73, done. Okay, we're gonna look at 74. 74, another, let me see, 74. Okay, 74 is another 5 minus 3x. Then you do x squared plus 8x plus 6. Always check if you need to, you can cancel. So 2x plus 8 is not. So split it up. Okay, split it up. This would be, splitting up shouldn't be an issue. Splitting up is a 2x plus 8 plus cb over squared plus 8x plus 6 dx. So you split it up. So for the a and b, side quest a bit. So 5 minus 3x equals to 2 a 2x plus 8 plus b 2a equals to minus 3. Then 5 equals to 8a plus b. So a is actually equals to minus 3 over 2. B is equals to 5 minus 8a. This one, 5 minus 8a plus 8 times 3 over 2, then it will be 17. Okay, so that's it. Okay, so this guy would be negative 3 over 2, 2x plus 8, x squared plus 8x plus 6 dx plus b will be 17. Complete the square will be 4 square minus 60 minus 10 dx. Okay, so I complete the square here. 4 square is minus 4 square minus 16 minus, yeah, that's it. Then what we do is this guy, it's just negative 3 over 2. This is just cancelling, so x squared plus 8x plus 6. 17 over root 10, tangent inverse x plus 4 root 10. Okay. Oh. 70. Why is it different from the answer? Wait, let me see. Can we factorize the denominator? We can't, right? Yeah, this one is. Okay, let me double check. My answer is different from the answer key, so it's the same. I think it's the same, but x squared. Yeah, it's the same. Oh, shucks, wrong. My goodness, sorry, I'm not thinking straight. My bad. Okay, I'm rushing. So this is not tangent inverse. My bad. Minus sign here. So what you need to do is use the ln. Thankfully for answer key. The ln is this guy here. So what we need is this x squared minus a squared. Yeah, so using this guy, bro. 1 over 2a ln ln x plus x ln 2a ln x 4 minus x over x plus 4 plus root 10. Okay, great. Mistake. Okay, so simplify everything. Yeah, so the answer is correct. This guy will be negative 3 over 2 ln x squared plus 8x plus 6. 70 over 20. Wow. Nope. X minus a. X plus 4 plus 110. Okay, plus c. Great. Done. Careless. Okay, great. So let's look at part 75. Thank you, guys. Okay, I think okay. Man, oh my tian. Okay, 75 would be quite okay, I feel. We've done several of these just now. So 75. What you want is you want cosine 5x sine 4x, right? dx, right? So the idea is you just want to reduce this to degree of 4, power 4. So what you do is you just let u equals to sine x, okay? So like I say just now, this integration here is not really in the syllabus, but it comes out in school examination. So just practice lah, okay? So differentiate sine x will be like if it comes at A level, likely it will be scaffolded, I think. Sine, differentiate sine will be cosine. So this will be cancelled. And what you get is 4. Then here will be cosine 4x u4 du. Okay. So from here, what we get is 1 minus sine square x. Okay, maybe I just do this carefully. This is cosine square x u4 du. So this will be 1 minus sine square x square u4. Okay, this entire thing here is your u square. So this is 1 minus u square u4 du. Okay, so 76 is it? 75. 75 will be just normal expansion there. So minus 2u square plus u to the power 4, u4 du. This will be u4 minus 2u6 plus u8 du. Then you just do this as u5 over 5 minus 2 over 7 u7 plus 1 over 9 u9 plus c. Okay, that's that. This is what? Question 75. So that will be 1 over 5. My u is what? Sine x, right? The sine 5x minus 2 over 7. Sine 7x plus 1 over 9 sine 9x plus c. Easy game. Okay. Just okay, not easy. But yes, you get used to it, then you'll be fine. Not too bad. Okay, let's look at the next one. We have got, thankfully, is 70. Wow, my tian. I just got someone 76. What's 76? Oh, 76 is similar. So 76 we solved it just now. So we have got 76 is square root. Did I solve it the same? It was the same question just now. It was similar or same, I'm not sure. Did I put a duplicate again? So this is similar to, I don't know which one. We did something similar just now. What's it? Oh, similar to question for D2. Wow. Okay. So what you need to do is same thing. What I want is to remove the bugger on top. So I will suggest we just multiply by this guy. Okay, maybe I'll just write this down. Minus 2x and 1 plus 2x. So it's about manipulation. I think yeah, it's about manipulation. So this is 1 minus 2x dx. So this guy would just be 1 minus 2x squared. 1 this whole thing would be, you see that? Okay, so I think split it up shouldn't be an issue. This would be 2x squared dx minus 2x over 1 minus 4x squared. This guy, cancelling method, just let your u be that, cancel the one on top, integrate. This one, just mf mf 27. Easy game. 2x over square root, let u be du minus 8x. Okay. Cancel this out. Will be 2x. Because this cancel will be 1/4 lah. So I presume you now do that. So this is half divided by half, is 2. Sine inverse 2x plus half square root 1 minus 4x squared plus c. Okay, question 76. Answer correct. Okay, let's look at 77. Wow, okay, 77 is also similar to okay. 77 is also similar to, I don't know which, just so we did something, the 10 one, I don't know which. Similar to question, bro, where is it at? My 10. Too many questions. Similar to question 44. Okay. Similar to question 44. Then what you do is so revise this, because recently there's a very a lot of our schools like to ask this question recently, like the recent papers I've seen. So but it's okay. What you do is same thing, you just multiply 3x, the 3x, so that you get the same power. There are more than one way to solve this lah. So I'm just gonna do the usual way that we like, because it's easier. E3x, then minus plus e minus 3x. Okay, dx. Then your u is just e3x plus e minus 3x. This is just u e3x plus e minus 3x du 3e3x minus 3e minus 3x. Yeah. That means anything. So I get cancel it out. Cancel it out. This will be 3, right? There's 1/3 ln u. Yeah, here you go. This is one of the more efficient way of solving it. 77, right? Okay, answer is correct. Then we look at 78. Wow. Okay, so this is important. 78 and 79 addresses an issue, which is what we mentioned just now. So if you look at 78 and 79, the concern is, what's the difference between ln 3x square versus ln 3x square? Okay, so the difference is stark. Ln 3x square is ln 3x multiplied by ln 3x. Okay, so don't get confused. Just then, after which ln 3x square, this is 2 ln 3x. You can apply the logarithm rule where the power can just be brought down. Okay, so don't, 78 is a secondary school question, which is it's just a secondary school integral. There's nothing fancy there. Ln 3x square dx. The 2 bring down, then this is actually 3x dx. So you can just get integration. This is Oh, no, you can't integrate. Sorry. What I'm saying, you can't integrate ln, right? You have to use by parts. Okay, how do you do that? There are a few ways. Okay, so you can just ln 3 plus ln x if you want to separate it out at the start. But I just put a 1 in front. So ln to 1 dot ln 3x here. So this guy, this is your dv dx. Then this guy is your u. So anyway, u is equals to ln 3x. So du dx equals to 1 over 3x times 3, which is actually 1 over x. dv dx is 1, v is equals to x. So this is 2 uv minus v du dx. Okay, then this will be 2 ln x x ln 3x minus, this is 1, right? So you get x. Okay, this is just 1. So integrating 1 just x. So this is answer 478. I'll leave it like that. Lazy to expand. Okay, good. Then 79. Then you have got, oh wow, okay, now I understand. So this guy here, just be careful. 79. 79, you have got ln 3x squared dx. So similarly, this one has to be by parts, right? Because we can't directly integrate, what do you call it, ln. So put a 1 there. So you just put this as 1 times ln 3x squared dx. So your u should be ln 3x squared dv dx is just 1. Then your du dx will be 2 ln 3x 3 will be just x. Okay, so just be mindful. This will be 2 ln 3x over x. So when you differentiation is important. Just chain rule 2 multiply ln, this is 1. Then you differentiate the inside 1 over 3x times 3. Then this will be uv minus uv du dx. Okay, so you get rx square minus 2 ln 3x dx. Okay, ln 3x we dealt with it just now. Ln 3x. We have 2 ln. Oh, okay, we have this guy. So I'm just gonna substitute the entire thing in. So from this 2 here, this guy is just from question 78. Lazy. So this guy will be just x ln 3x. Then you just take cause 2 ln 3x is this is 2 ln 3x, right? So this is 2x ln 3x. Minus 2x plus c. Okay, then you just write down the entire thing, simplify it. This will be x ln 3x square minus 2x ln 3x plus 2x plus c. Yay, easy game. Okay, great. Done. 80. Oh my goodness. 80 is fun. Oh, 80 is fun. Okay, great. 80 is so you have this guy here. 80 you have got integration of 3 minus x squared dx. So I'm not sure if you use by parts, you can solve this. You can try. You put the 1 in front. But I think I would rather do this. Then I'll get this as ln root 3 plus x. Root 3 minus x. Oh, yeah, correct. Then, isn't it easier? Then this would be like ln root 3 plus x plus ln root 3 minus x dx is 80. So then when it's so complicated. Yeah, I think you can use by parts there, but I'm just going to do this case here. Okay. So this guy will be, oh crap, I need to do ln both sides. Because I do ln next once. Or should I just do by parts? Okay, I'll just screw this. But you want to do this, you can. You just do ln x. Then I don't have a ln x integral, so I might as well just do by parts at the start. Okay, so that's the idea. Okay, I'll just screw this. So this is 3. I'll put a 1. 3 minus x squared dx. Let the dv dx, let the u equals to this u here. Equals to ln 3 minus x squared. Okay. Then you let your dv dx be 1. Then du dx will just be, oh, my pen is maybe running out of battery, but I don't know. Okay, so this will be 1 over 3 minus x squared minus 2x. Then v will just be x, right? Okay. Then uv, so it's x ln 3 minus x squared minus of v du dx, so it's plus dx. Okay. Okay, let's keep a few steps now. So okay, then then this is okay. Ln, we can just put a modulus so that, okay, this guy here, not too bad. Do a long division. I'll just do it then. Minus 3x squared plus 3x squared minus 1. So there you go. So this will be x ln 3 minus x squared plus 2. Remainder is 3. Oh, okay. Okay. This you can alright, this one you could just use MF. Yeah, this is just MF. Or you can just partial fraction, but I think MF is faster. Because it's already done for you. Actually, the MF formula is done by using partial fraction anyway. So we get the MF 27, which is this guy here. I mean, this guy MF. The one that I just now carelessly thought it was tangent inverse. So we're talking about the a squared minus x squared. So I'm going to use the a squared minus x squared there. Is x ln 3 minus x squared minus 2x plus 6. A squared minus x squared. 1 over 2 root 3 ln root 3 plus x root 3 minus x plus c is x ln 3 minus x squared minus 2x. 3 over root 3 is root 3 actually. But if you don't root 3 over, root 3, then you can just okay, maybe just leave it as 1 over root 3 also can. 3 over root 3. Okay, you can put a modulus or not, it's fine. This guy's root 3 lah. Okay, great. Good job. Let's look at the subsequent one. Who else? 80. Oh my 天. How to Oh, 80. Oh, 80. Oh, okay, 80 done. Okay, 81. How many more pages I have? 81. I'm not sure if you can see this, but my finger is numb really. But 81. 81 is 81 is another trigo identity here, so don't get too worried. Okay, I think the main thing is to understand that if they are not in the same angle, the general rule of thumb is if you can change it to the same angle, life will be good, right? So you're not sure what this is 2 sine x, cosine x, dx. Cancel it out. You get 1 over cosine x dx. Then don't forget, secant x can be integrated via the MF20 MF27 ln secant x plus tangent x. So this will be half ln secant x plus tangent x plus c. Easy game. Not bad. Then we look at 81. What's 81? There's 81. So let's look at 82. I think it gets harder. Oh, wow. Okay, this is the one. Cosine square. Okay, come. Look at that. Integrate by okay, this one usually they're careful, but of course if don't expect them to always careful. Right? So what you do is you try and you see this secant here. Your best bet is to make it tangent secant square. Okay, then you try. So this is secant x multiplied by secant x. So this guy, the top will just be secant square x. Then this guy, sine x multiplied by secant is 1 over cosine x. So this one is 1 over cosine. This is cosine x over cosine x. So when you manipulate this guy, it will just be secant square x over tangent x plus 1 dx. Okay, so then it suddenly becomes a cancelling method. This is secant square x over u du, then this will be secant square. You get ln 1. You get ln u, so it's tangent x plus 1 plus c. Okay, that's it. That is your A82. Okay, you get that tangent x plus 1. Then we look at 83. Oh, wow. 83. How would you do it? Okay, the 83 is definitely by parts, not an issue, but usually what I would like to do is to see if you can, I think, don't just jump to the by parts, because sometimes, say if you have ln x squared plus 2x plus 1 dx, this can be easily done by just factorizing this out, then the 2 bring it down, then it's easier to just, but it's still by parts. Okay, anyway, maybe it's a less complicated by parts, but generally you see if you when this, as far as quadratic expression is concerned, try to factorize it. But anyway, this guy, obviously we just have to do by parts as usual, so it's not like a hassle. So let u be ln x squared plus 2x plus x plus 2. dv dx is just 1. du dx is just 1 over x squared plus 2x plus 3. 2x plus 2. Okay, then v is just x. So there you go. uv, so it's x ln x squared plus 2x plus 1, 2 square. X 2x plus 2 multiplied by x over. Okay, multiply them. Then what we get is x ln x squared plus 2x plus 2 minus of can I factor the 2 out? Lazy. Okay, so it's improper fraction, just do a long division. You don't need to think so much. So just do a long division. X squared plus 2x plus 3 x squared plus x. So this is x squared plus 2x plus 3 x squared plus x squared plus 2x plus 3 minus x minus 3. It will be plus 2 minus of 2, 1 minus x plus 3 over x squared dx. Then this case here, you just x ln x squared plus 2x plus 2. This is, oh, I need to, this x integrating x is just 1. This will be what? Oh my tian, this one need to, okay. This one need to use split up because 2x plus 2. So this would be x plus 2x plus 2, right? 2x plus 2. 2x plus 2 is x plus 1. So you can just split up like that. You don't need to always do a plus b square, okay? But it's very quick to see this way. Then I'm gonna just, how long is this question, bro? Why is, okay. X squared plus, so this is speed up method. The rationale is because I can see the speed up method. This 2 multiplied to be 4. Complete the square, 1 square minus 1 square. 1 square, bro. 3x square. X square. Did I do wrongly? Oh my goodness, I did wrongly. Ayah. Copy wrongly. Okay, so 2. There you go. Maybe I'll fix my work. This is 2. I change this to 2. This is 2. Ouch. Very painful. 2x plus 2. Ouch. Okay, never mind. I'm just gonna erase this entire thing because I think it's very hard to. 2x plus 2 times x. So 2x plus 2. This is 2, obviously. Okay, then I'll do a long division here. Okay, nothing much then. X squared plus 2x plus 2. X squared plus x 1. X squared plus 2x plus 2. Minus x plus minus 2. Minus x minus, okay, that slowly. Slowly. Wait, 2x plus 2. This is which question? 83, yeah. Okay, so this will be maybe I just multiply this 2x inside. So 2 1 minus x plus 2. Okay, great. Then there will be 2x, correct? 2x plus 2. This is x plus 1. This is 2. Okay lah, nothing much. Not much damage there. This is 2. Okay, great. Done. Tangent inverse x plus 1. Tangent inverse. This is not. This is 2. Alright. That will be 2x plus 2x. Okay, so this will be just cancelling method. The 2 will be there. So this will be x ln x squared plus 2x plus 2 minus x plus ln x squared plus 2x plus 2. Plus 2 tangent inverse x plus 1 divided by 1 minus x. This ln, this is 83. X ln 2x. I don't know, man. Let me see. Ln 2x. Let's bring the 2 out. Okay, if I make any careless mistake, I will just update the I'm pretty sure I'm doing 100. Definitely there's some careless mistake which I didn't. It's x squared plus 2x minus 1 minus 2. I will update and put in the description. So please check. This is 1 minus x plus 1. This is 2 plus x squared. X plus 1 because it's 2x plus 2. 2x plus 2. This is 2. Yeah, there's a minus 2x there. I think there's a minus 2x there. Okay, step. Let me check answer. This is ln. Mm, 2x. Yeah, looks correct. Okay, okay. Great. Let's look at the next one. Part 84. 84 is okay. Not too bad. 84, what we need to do is obviously do the separate. I don't know. 84 x4. Can we simplify? Put the x4 out. That'll be x plus. Okay, maybe I just don't skip step first. This is 4x plus x. 84 x5 plus x4 dx. This would just be. Oh, factorize x plus 1 out. Wow. Okay. Can we separate this out? So I hit like x4 there. Oh, wow. Wow. I see. Wow. This is 2x plus 1. Okay. The reason why I'm impressed is because some of these questions are added by our teacher, so I do not know what's going on. What to expect. Wow. Okay, great. So you can cancel this. Oh, this is interesting. So this is 1 over x plus 1 plus 2 over x4. So this is just a simple ln x plus 1. Can we just do this like x minus 4 here? Is 2x minus 3 over minus 3. Okay, so you get minus 3 minus 2 third x power 3. Okay, interesting. Okay, great. That's it. Look at 85 using substitution. Going to reaching the end already. Okay, can 85. 15 more questions. Easy game. We're given the substitution. So we're just gonna do it x4 minus 4 dx. So x squared is equals to 2 secant u. You see, there are a lot of secants around when it comes to trigo. Okay. So you can either use implicit differentiation, differentiate with respect to x, so is 2x equals to, oh my tian, du dx. Okay. So you pull out the MF26. Secant x is differentiate secant x is secant x tangent x, okay? So secant x tangent x, this is 2 secant u tangent u, then du dx, okay? So dx can be written as 2 secant u tangent u over 2x du, okay? So if your school don't allow this, just erase it, but I'm just gonna rewrite this. Like I said, it's, yeah, I have nothing to say already lah. I think it's okay. It's no point like arguing. Don't allow, just erase, it's fine. Okay, it's nothing inherently wrong. But I'm not gonna. So x squared. So this guy here, you have got x would then be square root 2 secant u. I'm not sure whether the I never checked whether this is solvable, but if there's a typo, I will let you know. So this is 2 secant u. Secant 4 will be 2 secant u. It doesn't seem like that's typo. Dx will just be that entire thing there. So I'm gonna just put the entire thing there. It looks ugly, man. 2 secant u tangent u over 2. So the 2 can cancel, so x. Okay, the x as well, so is x is actually 2 secant u. So everything has to be in terms of u, right? You don't leave it in terms of like so anyway, this is x lah. So this is x squared. I'll leave it as x first. So the x squared, simplifying it, is x squared. Then this will be 4 secant square u minus 1. Okay. Similarly, understand that tangent square a plus 1 is secant square a. So this secant square a minus 1 is tangent square a. So x squared is 2 secant u. So that will be my 2 secant u. Secant u can cancel. It's good that we can cancel a lot of things. So root 4 is just 2. Then this will be tangent square u du. Cancel. Wow. Cancel this one. Cancel. The tangent and the tangent can cancel also. This is a great total of 1. So this is 1 u plus c. Okay. A u. So that will be it. So now we need our u back. Our u would then be so this is u. Our substitution is x squared equals to 2 cosine u, right? So cosine u is equals to 2x squared. U is equals to cosine inverse 2 over x squared. So we do is just replace this guy for cosine inverse. We go. Okay. Yep. Is that done? 85 done. Let's look at 80. Oh, okay. 87. Okay. I think 80 to 89 is not too bad also. Like 87 would be that. 87, what we have is sine square. So it's like really know your trigo ratio well enough to solve them. So this will just be sine. Just separate them. Plus 1 of cosine square. Then you need to know that you can actually integrate secant square. So this is just tangent square x plus secant square x dx. Okay. Then what we get is tangent square a plus 1 equals to secant square a. You get these two because you can't integrate this, but you can integrate that too. Okay, that's the idea there. So secant square x minus 1. Oh, okay. Could have changed at the start, but it's okay. So dx, so this will be 2 secant square x. This is probably not the only way to solve it. Okay, tangent x minus x plus c should be 87. 87, bro. Yeah. Then we look at 88. 88. Okay, so 88. Auspicious number, bro. This one. $88, what we have is okay, this how come we have so many of this? They're related, I think. Do long division, they're all the same, but just do long division. Okay. This one. Okay, let's look at part 88 to 90. So if I've done any careless mistake, just put in the description, the comments below. But I will run through again, and I will check if there's any mistake. Then I'll pin it in the description also. So then you'll please check, okay? But we update the soft copy. Let's look at 88. 88, how do we do it? Okay, 88. Just do a long division first, as long as it's not, what do you call it? Proper fraction. You just do a long division, so x squared minus 3 minus is 3. So then this will just be 1 plus 3 x squared minus 3. Okay, dx. Then this guy, you can just use MF26, so it's x plus 3 1 over x squared minus root 3. You can obviously use partial fraction as well, but because it's given in MF26, so I'm just going to use x squared minus a squared here. Okay, so that will be x plus 3 1 over 2a check MF26, 1 over 2a ln x minus root 3 x plus root 3. Okay, simplify it, you get 3 over 2 root 3 ln x minus root 3 x plus root 3. Yeah, that's about it. This is question 88. How come it's a bit different from the answer? 88 root 3. There's an x there. Oh yeah, correct. Answer is correct. No, the x is behind. There's that. Let's look at 89. 89 is the same thing. 89, before you do, just do long division. Okay, this guy, you just do long division. X squared minus 3 x cubed minus 3 x cubed minus 3x 3x minus 3. So this guy would be x minus 3x minus 3 over x cubed square minus 3 dx. Okay. Okay, that's it. Then what I'm going to do is just x squared over 2 minus of 3x over x squared minus 3 minus of 3 x squared minus 3 dx. This guy, we have it. So this is just cancelling. This guy is just what we did just now. Use MF26. So be careful of the expansion here. You expand this guy. So this will be positive. So I think this is also another cause for careless mistake there. 89. We have, okay, I'm going to use MF10. So this will be half x squared minus of 3 over 2 ln u, which is x squared minus 3. Let u be, okay. Then this guy just use MF26. So the MF26 is the same thing here. It's actually the same. I'm gonna just put 3 x squared minus a squared. X squared minus a squared is 1 over 2 root 3. X squared minus a squared 1 root 3. Then ln x minus root 3 x plus root 3 plus c. Okay, that's that. Then we're just gonna do everything else. 3 over 2 ln x squared, just write it nicely. Cause yeah, of course, if you want to rationalize and make it nicer, also can. But I'm gonna just leave it as it is. Let's see. Okay, that's that. What's this? This is question 89. Did I do wrongly? X squared. Sharps. X squared 3. Nope. Separate it. So you separate this guy to cancel. Then this guy to cancel this guy. Then minus it plus 3. This guy is to cancel this guy. Okay, it doesn't seem like. I'm not sure. B9. Wow. Okay. Wait, I think I got careless, huh? Where is the careless mistake? What next? X cubed. Can't seem to see it. X square minus 3. 2 root a. 1 over 2 root a. Easier. 2x 3 minus x square minus 3, x squared plus 3, 3x, 2x. Okay, well, I separate it properly. Doesn't seem like there's any mistake. X squared, x minus 3x. Three. Cancel 2x 3 over 2 ln u x squared minus 3x plus 3. Two over a. Okay, I think it's fine. I don't know. Probably there's another way to solve this. The solution probably is another way. But what other way can I do? Interesting. Can I integrate it? Okay. Anyway, part. What do you call it? Part 9. Question 90. Question 90. We have got. Question 90. Bx 4 over x. So just do a long division, same thing. If it's improper, just do a long division. X squared, x4 minus 3x squared. There will be 3x squared plus 3. 3x squared minus 9. This is 9. Okay. This will be x squared plus 3 plus 9 over x squared minus 3. Oh, this is not too bad. Question 90, in fact, is the easier one. We'll get, let me check. X squared minus x3. Oh, 3x squared minus 9. 3x squared minus. Okay, wait. So this is x cubed over 3 plus 3x plus 9. There you go. There will be a keying calculator. That's using the MF. 1 over 2a. 1 over 2a. 1 over root 2, root 3, ln plus c. That's it. Keying calculator. I mean, not keying calculator. Just rearrange it and write it nicely. Okay. Okay, great. Interesting. Okay, the question 91. Okay, if I have any careless mistake, I will just update in the description, but I check. Seems like it's okay. But I may miss some stuff. Okay, so question Same thing. This one is similar to last time question. Goodness. Yes. Okay, so 91. I'll upload the handwritten solution to the website. So if you all have any e10x minus 6, e10x plus 1 dx. Okay, so like I say, this integral here is not directly in the A-level syllabus, or like I think in exam if it will ever come out, it will be like scaffolded. Okay, but recently a lot of I'm not sure. Yeah, but anyway, this guy just multiply minus 5x, e minus 5x. Okay, so this guy will be 6e 5x minus e minus 5x over e 5x plus e minus 5x dx. Your u is equal to e 5x, right? Then plus e minus 5x. So this guy will just be 6 1 over u e 5x minus e minus 5x. 5e 5x minus 5e minus 5x. Oh, it's just 1 and 1. Rule 5. It's 6 over 5 ln plus c. Okay, that's 91. 91. Great. Anyway, ex is always positive lah, so you don't need to put modulus. But even you put modulus, is fine. Okay. If your school say cannot, then just remove modulus. But actually, it's the same thing. So don't sweat over it. That's okay. 92. 92 looks cheap, but it's okay. It's just a facade. Okay. 92, you have got x cubed plus 2x squared plus 2x plus 1. So I think the first thing is to obviously you need to factorize the denominator. If not, you can't really, you need to do partial fractions. Have to. So I'm going to just write this down. X cubed plus 2x squared plus 2x plus 1. This will be x squared, x plus 2. Oh. Can I factorize the x plus 2? How would I factorize this guy? X squared, x plus 2. What about... We know that you can just key in calculator and factorize this guy, x to the power 5. I think just use calculator. So 2, 2, 1. 1, okay. So you know that the root, one of the root is actually x plus 1. Actually, you can see that when x is minus 1, it will satisfy the equation. So this is x squared, x cubed plus x squared minus of 3x squared plus 2x plus x. This is x squared plus x minus of plus 1. So this is plus 1. Oh, right. Factorize it out. So you found the root. Okay. Then what you do is, obviously, this one you have to do partial fraction. It's always a degree lower. So px plus c x squared plus x plus 1 dx. Solve for partial fraction. So a this is equals to x plus 1 equals to 1. So you just let x equals to minus 1. Then a will just be 1 over 3. Then you compare the coefficient of x squared or constant. It'll be faster, right? A plus c equals to 1. So a is equals to c is equals to 1 minus a, which is 2/3. You compare the coefficient of x squared. Then you have got a plus b equals to 0. So b is equals to minus a, which is equal to minus 1/3. Okay, maybe that's the case. So this guy will just be 1/3. X plus 1. Minus 1/3 x plus 2/3 plus 1 dx. So then you just do the normal, split it up. 92. Wow. Okay. So that will be okay. Let me check first. Something's wrong with my partial fraction. Hold on. Let me check. A square. Oh, my天. Okay, I got wrong. So this is my wrong. Minus 1, this will be 0, so this is 1. Then C will be 0. Then A plus B. C will be 0, then B will be minus A. It will be minus 1. Okay, thankfully. Minus 1. Okay, so there will be minus 1. It will be minus 1. Minus X. Okay, great. Well, this is easier. So this is ln x plus 1. Then you just split it up. Split up in the sense that like you have A, 2x, same thing, P, 2x plus 1 plus B over x squared plus x plus 1 plus Q. Then side quest again. You have P, 2x plus 1 plus Q equals to minus x. 2p equals to minus 1, p equals to minus half. P plus Q equals to 0. Q equals to minus p, which is half. So if you settle this down, it'll be ln, it will be minus 1/2. And Q will be plus half. X squared plus x plus 1 dx. Okay. That's that. Then you just do your normal integration. Minus half ln x squared plus x. This one just complete the square for the denominator. We just x. Okay. One quarter, 3/4. Tangent inverse ln x plus 1 minus half ln x squared plus x plus 1 plus half tangent inverse x plus half over square root 3 over 2 plus c. That will give us a grand total of 1 over a. Sorry, 1 over a. That will be ln x plus 1 minus half ln x squared plus x plus 1. Then this will be half root 3 a tangent inverse 2x plus 3 over 1. 2x plus 1 over root 3. Just multiply by 2 lah. Easy game. Oh, I'm getting very tired really. I don't know, man. I'm just solving. I don't even check. Okay, there's no careless, so thankfully. Let's look at 93. Okay. 3 is, oh my 天. 93 may not be so straightforward, but also quite fun. Let's see how. 96 is the difficult one, I think. 90, 100 is okay. 100, split it up, really work. Okay. So let's look at 93. 93 will be, hopefully can cosine x plus 1 dx. Okay, so this one is definitely a cancelling method. So what you need to do, maybe change to any of the 8 expression, then maybe it'll help out. Okay, so the good thing is we have cosine 2a equals to 2 cosine square a minus 1. Oh, this minus 1 can remove the plus 1 there, so it's good. So 1 minus 2 cosine sine. So I'm going to use this guy. My a now is actually just x over 2. So essentially, half an angle will just be 2 cosine square x over 2 minus 1 plus 1 dx. Okay, this guy, when you do it, you left with cosine square 2. That's good because what happens here is we get a root 2 outside. Cosine square root will be cosine x over 2. There's nothing more than a secondary school integration, so 2 sine x over 2 over half plus c. It is 2 root 2 root 2 sine x over 2. So you change to any of the 8 expression to be able to integrate. Okay, so that's that. Then we look at 94. I think 94 is not so straightforward, but we can try. Sine, is it the same? So you see this same thing. What we need to do is also remove the sine x. So that's why I say if you need to pick a interesting expression, it will be this guy, because this guy has got like 3 equations, right? So we have got like 1 minus 2 sine square a. So sine square. Oh, we can't do that. Let me think first. No, we can't. Okay, this one is where we become square, sine square. What if I let this be? Okay, this is an interesting one. Then we have to use okay, this one is not like, it would likely will just careful for you. So sine 2a is equals to 2 cosine a cosine sine a cosine a sine a cosine a. So essentially I could just use this as 2 sine x over 2 cosine x over 2. This b here will be cosine square x over 2 plus sine square x over 2. Okay, don't ask me how, but I think likely they will just ask you to careful. Then you realize this guy nothing more than just a square minus b square. So this guy will just be cosine x over 2 plus sine x over 2 square dx. Okay, so this will be cosine x over 2 plus sine x over 2 dx. Then that will be grand total of 2 sine x over 2 minus 2 cosine x over 2. Divide by half, that's why it's 2. Okay, is that done? So we're going to look at 95. 95 is the same. 95 looks difficult, but as you can see, what you need to do is just to, okay, this is not directly in syllabus also, so but it happens in the exam. So you just let u equals to tangent x. Okay, because syllabus only have 2 lines of f1 and fx. Okay, so this is u square du, this is secant square x. Cancel it out. You left with 1 over 1 minus u square du. Okay, so this guy here, you just use your, what do you call it, the MF. This one would be 1 over 2a, right? Then you have that weird thing there. So this will be 1 over 2a ln 1 plus u, 1 minus u, right? Plus c. So there's that. And then what I'm going to do is just going to put that there. Ln 1 plus tangent x, 1 minus tangent x, plus c. Okay, not directly in the syllabus, but happens in school exam. So just take note. But I cannot tell whether, yeah, it's just it's okay. 96 is interesting. Okay, 96 is one of the interesting ones also. Let me see. How would you do 96? 96. The 96, same thing. Likely will be what do you call it? Will be you'll be told to sort of like, what do you call it? You'll be told to scaffold. There will be a part 1, then the part 2. Okay, so that's the idea. So how do we do 96? Actually, what I want to do is actually I want a multiple of sine x here, a. Then maybe I want a multiple, differential cosine is negative sine, right? So maybe I want a negative sine x plus cosine x. Okay, so they'll ask you from first part to do this. Why? Because later you'll see why. I think this is it. You can see that if I were to, so you solve for a and b here. I'm coming to an end, bro. I'm coming to an end. I'm not going to do this anymore, bro. No. A minus b. Okay, you see the coefficient a plus b is 0. A minus b is 1. So this is minus half, right? So I need this to be half. Yeah, okay. Then a plus b is, you solve this to be a plus minus b is half. Then after that, a plus b is a plus b for the cosine a plus b is 0. So when you solve this, you realize that, how come? Can we solve this? Minus 0. Or is it too, it can't solve this? I'm not thinking straight, bro. Yeah, okay, we can. A is equals to b is equals to half. B equals to half. Yeah, b equals to half. Okay, great. Then the reason why you want to leave it in this way is because this guy, when you separate it, minus half cosine x plus sine x over cosine x plus sine x dx, the b would be half minus sine x plus cosine x. Is because this guy can cancel off and become a grand total of 1, which is good life. Good life for you, good life for me, everyone happy. This guy, use cancelling. You just let u be that guy below, man. This guy. Let u be this guy. This is a u. Okay, what's that? Minus half 1 dx. I'm coming to an end. Dx plus half It's minus sine x. Du. Cosine x is negative sine x, bro. Negative sine x plus cosine x. So I could, my b is positive, right? Yeah, b is positive. Why is it different? Half. It should be the other way around, bro. Shucks. I think I did something wrong. A minus b is 1. A plus this one should be plus, bro. This is minus, right? Because this one minus x. Did I write wrongly? Minus sine x was b cosine x. Cosine x. This is half. Why did I get the wrong answer? 1 minus 1, 0. Oh, yeah. I wrote wrongly. Sorry. This is minus 1. Okay, great. This is wrong. This is wrong. Okay, great. Okay, great. Anyway, this is it. Cancel this will be ln, so log x minus half ln cosine x plus sin x. Okay, I repeat, this question likely won't come out as it is, like one question like that, because it's not fair. Okay, it's sort of like oh my天, my eraser is not working. Oh, it's half x minus plus minus, so this would be, I wrote wrongly, so this is plus, sorry, my computer just undo some of the thing that I did just now, minus 1 minus. So they was careful for you. It won't be a directly done it like that. So this is half ln cosine x plus sine x plus c. Okay. So let u equals to cosine x plus sine x. Yep, done. Okay, let's look at 97. Oh my天, 97 is the last 4 is not easy, man. It's, let me see. Oh, the last 3 is last 97 maybe take some time. Okay, let's do it. 97 is also another common question. I don't know whether it's common or not, but you see in school exams also. Is by parts. Okay, so you put a 1 here. Then you just let your u be sine ln x. Then du dx will just be cosine ln x 1 over x. Okay, then your v will be the 1. Then v will just be in dv. Your dv dx will be the 1. Then the v will just be x. So then this guy ux will be x sine ln x minus of x cosine ln x over x dx. Okay. Then after that, what you do is x sine ln x minus cosine ln x dx. Same thing, do a 1 here. So do another by parts. Should be able to get the answer there. This is wrong. Then what we get is u, it's like u1 is cosine ln x as well. Then dv dx is still a 1. Then du d1 dx is just negative sine ln x over x, v equals to x. Okay, so when you do your, what do you call it, your by parts, this is uv again, x cosine ln x plus, right, because the negative there, then there'll be sine ln x. You get the ln x again. Because these times this will cancel off. So same thing, if you are the part of the problem and part of the solution, then you are the problem, okay? My goodness, they just erased I think too many questions. Okay, later I need to use a new document. I think it died. Unable to save pro. Died really. Okay, let me just... Okay, later we use a new document to cosine. Does it? Says that. Okay, sine x. Wow. Okay, I think that's the maximum my PDF reader can take it for 97. So I may need to separate the file. Okay, so this is part 1. Here's a part 2. I need to redo everything. Man, check. Okay, 97. So just u equals to sine x. I should have splitted it up. I think even is too much math for the PDF reader. So du dx cosine ln x over x. Okay, so I just presume you all know how to do the integral here. So this will be x sine ln x minus of x times ln cosine ln x over x dx. Then this will be x sine. So this is a common questions you'll see in some of the school paper as well. So yeah, give it cosine ln x. Then you do another by parts. u1 cosine ln x. Then dv dx is just 1. du1 dx is just negative sine ln x divided by x. Chain rule. Then you do another time. X sine x ln x. Minus of uv, which is x cosine ln x. Minus of plus sine ln x dx. Yay, great job. Okay, now same thing. If you are the part of the problem and part of the solution, then you're the problem. So this is the same thing that we just let this be I, right? This guy is just I. Yeah, just I here. So this guy will just be I equals to x sine ln x minus I. It'll be 2I equals to x. Plus c, okay, x over 2. There you go. Quite okay, yeah. Standard. Good. Thank you. Last 3. My goodness. When will we end? Oh yeah, last 3. Okay, good. 98 is okay lah. 98, I don't think it's like a big issue there. So I'm gonna just 98. 98. So it's all about eyeballing, like know your trigo ratio well. So 98, it may look difficult, but it's okay. E tangent is E tangent x over 1 minus sine square x dx, right? E tangent x. This guy will be cosine square x. So you must always try and fish the secant square out, because tangent x and secant x, they are related, blood related. So this guy will be your u. Can cancel the guy in front. EU du secant square x. Then you get cancel it out. You get EU du lah. So that will be E tangent x plus C. Okay, that's 98. Then you do I'm gonna do 99. So 99 will be same thing. Cot square x over 1 minus cosine 2x. The main thing is to understand that if the angles are not the same, change it to the same angle. So we have got change it to, so cosine 2a is equals to 1 minus 2 sine square a. I'm using this because I can remove the 1 in front. Okay, the 1 in front is the annoying one. So cot, you can't, I'll just change it to cosine x over sine x for the cot, because I don't know, I just want to finish off this stream and go and chill, bro. This would be sine square 2x. What am I doing? Cosine 2 a. Okay, I'm just changing it to the root form and let's see what's going on. Then this guy will just be 1 minus the half below is half sine square. Oh yay, got awesome. Now this is a cancelling, obviously. There'll be a cosine x sine x. Okay, rearrange this as half. This is sine x cubed cosine x dx. Okay, obviously this is not the only way to solve it. I think there's probably another way to solve it. Yeah, this is cosine x, then u cubed du. Then will give us du, which is actually differential sign gives you cosine. Right? Then there will be a grand total of u minus 3 du, which is actually half u negative 2 plus 1. Then you just divide it by minus 2 plus c. There will be minus 1/4. Bro, there will be 1/4. 1/4 sine x minus 2 plus c. Sine x minus 2 is just minus 1 over 4 sine square x plus c, which is actually cosecant. Negative 1/4 cosecant square x. Okay, you can skip step whichever in between as long as you get the answer. Last part, finally. Let me see first. Last part, how to do. Oh, 100. Oh my god, I came to an end. Okay, Ken. Let's look at the not sian, man. Okay, bro, that's the thing. It's not about being sian or not. 4 hours, you finish every single thing, right? It lasts forever. That's the whole idea. But then next year, my J1 can use it. Subsequent year, my J1 can use it. Anyway, then anyone who wants to revise can just use this. Okay, but anyway, small price to pay. Small price to pay. My goodness, 5 hours and 30 minutes. Okay, let's go with it. The last one, I'm gonna do the last one, which is why is it not working? Okay, my PDF reader has got problems now because too much mathing, I think. Okay, so the 100, yay. Okay, this guy, how would you solve it? Let me see. Okay, is there a way to solve it properly? EX. By parts. I think by part will work. Maybe? I don't know. We put the EX, you wouldn't know. You can try. I'm not sure, man. I think this will work. So try. This guy will be U equals to E minus X, right? dv dx, right? Will just be E minus X over E minus X. I hope this works, man. Du dx minus E minus X. This is minus ln. Would it work? Oh, no, it doesn't. Wait, if I multiply by minus 2x, multiply by x, would it work? Ln minus EX plus 1. The other way around? Wait lah. Wait, my brain is not thinking. Minus EX. Okay. This one I think take note. This one you don't do by parts. Okay. For this case here, because by parts won't work, you will be alone, then after it will not be. They will let you know the substitution, so they'll let u be equals to E minus X. Yeah, this one I have to. So it's not part of a syllabus, but they will let you know the substitution. Okay. So I think I should just add that inside. This will be du minus E minus X. Then E minus X. This is u. So this will be u. We'll do this. Okay, great. Then this will be your u. So they will have to let you know the what do you call it? This minus, I bring it up. They will let you know the substitution. So this will be u cancelled. Long division. Minus 1. Okay. Ta-da. So this will be minus u plus ln. So this will be minus E minus X plus C. Okay, good job. Okay, you can leave the modulus there, or you don't leave it because it's always positive, I know. But if your teacher wants you remove, but if you leave it there, it's fine also. It doesn't, it's the same function anyway. So it is, yeah, that's that. Okay. So finish off 100 integrals. For this question here, the substitution they will have to give you. But then the next thing is if you need more practice question, then you could just go to our question bank. But put in the description, then you just look at the free. For our students, you can just look at the question bank and just do it. But for the public students, you can just look at the free content on our website and just start doing them. So for all the summary notes that we have, you can just purchase them either from the regular bookstore, like Popular, then or Shopper, or any like the online platform like Shopee and Lazada. Okay, thank goodness. Okay, so I finished off 100 integrals. I hope this will help you up your game in your integration. Okay, easy game.